So today, what are we going to do? We are going to continue with, let's see what the plan is. There is no plan per se. There are only guidelines. Uh, Documentation. Will we finish that and then go to parallelization? Or do you want to jump into parallelization fresh in the morning and keep documentation for like
We can
350?
begin from documentation. Parallelization is our regular stuff, so other stuff is kind of same, like part of process.
Like parallelization with OpenMP or MPI?
I put both. So basically what I want to talk about is the pinning behavior. Thread pinning
Oh,
and process pinning to cores and why to do it, how to do it.
okay.
Okay. Because
He,
normal MPI and OpenMP I'm assuming everyone knows. Or if
yeah, that's
someone
your
wants
call.
basic. Yes, no, it's not my call, it's the vote democracy.
Oh,
Hey, if, hey, Soumya, if you're planning to spend only half an hour on documentation, so you can start with that.
Okay, fine. So I'll do Doxygen. People who like Python and is there anyone who is coding exclusively in Python without any coding in C or C++?
Biplab from our group, but I don't think
Oh,
he's.
no, Biplab I talked to separately. Yeah, that is fine. Biplab, we have discussed exactly what to do with Python. Okay, then I'll focus on C++. Then Sphinx will be a side effect, a more nicer. Okay, by the way, the documentations we're talking about are basically like this. So you'll be generating something like this using Sphinx with browsable feature, basically a web page and sections and so on. And if you want to go into Doxygen documentation usually looks like this, for example. Open LPS Doxygen. So let me, yeah, looks like this. You can go read up on what functions are there and so on. So this is the rough overview of the basic documentation we'll be generating. There are other fancier packages for other languages, but for C and C++, Doxygen is the industry standard because no other packages can handle documenting template parameters or inheritance structures in C++ better than Doxygen does. Actually, what most other wrapper or fancier looking documentation packages do is they will internally call Doxygen's functions. So Doxygen is like the CMake of documentation, like in terms of industry standardization. So we'll start with Doxygen. So the first thing is you can, if you don't have Doxygen installed on your system, you can just do a sudo apt-get install Doxygen. It will install the package. I think I have it installed, so but you can do that. So once you have that done, let me quickly clone the repo that we were working on. So we are at clean slate, and the first thing we'll do is we'll document the code a bit. So sorry, new issue, document. We'll merge, so we'll directly create a merge request. Go here, git pull, check out. Okay. So now you have to tell Doxygen two different things. One is the basic metadata, like what is the name of your project, what is the name of your documentation file and all those things. And where are the documentation nodes going to be, the location of those paths, that is one. The second thing is the actual essays or comments or tutorials that you'll write. So we'll quickly generate a like skeleton documentation, which Doxygen can just look at your C code and generate by default. So what you do is you will create usually we already have a docs folder. So we'll go into docs. We were previously using this index.md. We'll remove that for now because we're going into proper documentation. The script or the configuration file that you give Doxygen, which contains Doxygen's metadata descriptions like project name and paths and all those things. That is called a doxy file. You can try to write your own doxy file, but it's a bit complicated. That's why Doxygen allows you to auto-generate a default Doxygen configuration file, which you can do by Doxygen -G. And you can name it, but usually the default is doxy file. Okay, just like Docker file we came across last session. The same way, it's a default doxy file will be generated by Doxygen using -G. If you go into it, it will tell you that, okay, these are the different fields that you can fill in. So my project name is my project here. By default, you can change it to, let's say, my thermal solver or something. Project number, basically these are version numbers. So once we start doing tagged releases and so on, this will come to version 0.1 and things like that. Brief is this solves heat equation. Logo pictures you can put and so on. Output directory is a directory in which you create the document, output the documentation files. And there are a lot of options. Most of these you need not bother about. The only thing that you need to, the only other thing that you need to not worry about, just take care of, is there will be something called the input path. So where are the files where you're going to input from? So usually that is the location of your source files relative to the Doxygen, this configuration file or wherever you're going to generate, called the Doxygen command from. So I am in the docs folder inside the root directory of the repo. So if I go back one, I'm now in the root and the actual source code will be in SRC. If you are commenting or if you're writing your comments in your include files also or header files also, then you can just put another line and sorry, I think you have to put a line break, and then, or you can put in the same line. That also.
If there is a lag.
There's a lag.
Yeah, a little bit. Yeah, maybe 4-5 seconds.
4 or 5 seconds. That's a lot actually. Okay,
Yeah.
let me see. Just let me rejoin once. Huh?
Is it me who is not getting sound?
Yeah. I'm not getting. Not hearing you, Sandeep. Oh yeah.
Sorry. Yeah. Yeah. I'll do that same thing once. Just check.
Yeah.
So A, B, C, D, E.
Yeah. Perfect.
Okay.
Yeah.
Just let me know whenever it's starting to lag again. Bangalore Wi-Fi apparently or internet connections are really bad nowadays apparently.
So are you at office today also?
No. I stayed back at home. But if home also, basically nature doesn't want this tutorial to go on. They're like everyone to themselves, no teaching. So SRC and include, you can put in your input paths if you want to rip off the comments or tutorials from these different folders. We'll come to the actual commenting and all this. Huh? So these are basically the input paths where Doxygen will search for comment files and things like that. And these are the file patterns which all files it will search your Doxygen comments for, and so on. And recursive, you can say yes if you want all the subdirectories to be searched also, which is usually the case. And there's one more thing which says that even if there are functions which do not have comments explicitly on them, then you can choose to either include it or not include it. Usually, when you have written a big code which doesn't have any comments and you want to document for the first time, it is usually a good idea to just use that by default, list down all functions, even if they don't have comments, and then try to start adding comments. So just 1 minute, I'm trying to see where that option is. Okay, just give me 1 minute. Again, I'll go back to my Andy repo to see what the syntax is, what the path is. Just give me 1 minute. Extract. Extract all means even if there is no comment, it will still try to generate at least a basic entry into the documentation for any function that is there in your code. Okay. So these are roughly the few initial parameters that you need to look or fill in or change. And now that you have done this, you can just say Doxygen on or Doxygen. Okay. Has done something, like generated some weird things. Let's see what it's done. So initially we had this just doxy file, and now it has generated 2 folders, HTML and LaTeX. So basically Doxygen can generate formats in documentation in HTML, LaTeX, MD, RSDoc, ASCII-doc, all different kinds of things. So we'll just focus on the HTML part because LaTeX I don't think looks very nice with Doxygen. Just let me check once. PDF somewhere. No, so okay. After the Doxygen generates these intermediate files, again like CMake, it effectively generates a make file. Only when you do make, it will actually create the output. So, for example, you can go here. Oh, sorry. You can go into HTML also and do a make. I think make HTML is there. Oh, sorry. So now you'll see some PDFs sitting around here. There's one PDF here, one PDF here. So let's just quickly see what PDFs have been generated. Okay. These are basically the pictures it's generating of so these are called UML diagrams. UML diagrams are basically used to sketch out the overview or skeleton of your software dependencies. Huh? So basically it says that app includes solver.hpp, IOStream from the C library, and CMan, and so on. So like this, you don't need to go through the source code. You can just at one shot view the entire thing, and so on. Okay. Now,
hey, Samadip, sorry. Oh, here, how did you make in Docs, right? In later.
Yeah. So okay, wait.
Sorry, I just missed that one part.
Yeah. Even I keep forgetting confusing the syntax between Sphinx and Doxygen. So let's go to the manual ones. So what it says is,
So, but what is Doxygen? It is scripting for LaTeX or?
So Doxygen, what you'll do is, let's show, okay, that's a good question. What is Doxygen trying to do? Suppose you have this code tree right here, this src include and so on. In your solver library, for example, you have these functions that you have written.
Okay.
Now you want to comment about these functions and create a documentation, like what does the function do, so that the reader can just, like, for example, I loaded here, right? Like there's this library, which instead of going through the source code, you can just in a web page, you can try to figure out what all this library has, what all functions. So for example, these are the list of functions in the library. If you just go to this, it will have some like overview and some, like it will show you what all functions it has, what the arguments are, Sometimes people actually write like words describing what the functions are and things like that. Okay. So this is like a more user-friendly browser for the code instead of actually reading the source code.
Okay.
So
So,
this is
can we say that it is visualizing that tree wala command in a better way?
tree. Which one? Tree? You mean this
The
one?
command line wala tree, yeah, it is visualizing it in a
See,
more readable form.
the command line tree is just listing the files that are there in your folders and subfolders. It will not list the functions that are there inside the files.
Oh, yeah.
Okay. Doxygen can list the folders or files that you include, but Doxygen's main thing is it will basically give you a nice syntax to write descriptions about each function, trying to explain to the end user how to use the functions. Okay. And generate these kind of useful diagrams for the developer's reference also. So Doxygen can generate user guides, it can also generate developer references. So how do you do it? That's the first question. So, the reason I would have come to how you do it, I'll just quickly make the initial thing once. So, there's a make command used somewhere. The question is, where do I use it? That's it, huh? You don't need to use make. That's beautiful. That's the problem with multiple. There will be index.html. Does anyone see an index.html? No. Let's see.
It's there, no? Index.html.
Is that, huh? Oh, it's already there. Okay.
Third column bottom.
Okay. So this is after you did. So basically, there's no need to do make. Huh? Make I think comes only in Sphinx. So forget about that make part. When I ran Doxygen, okay, let's just do it again once, just to make it clear. So I'll remove all these intermediate things which got generated. So you wrote this doxy file, modified like the default doxy file, wrote all these things, and then you just do Doxygen doxy file. Okay. It will try to generate something from. You give the paths of your source and include folders. So it has tried to pick up something from there. Let's see what it has picked up. So if you see, it has generated HTML and LaTeX documentation. If you now open it in a browser, HTML/, the entry point of your documentation from Doxygen is usually index.html. You can change the name of it, but usually all websites, the root or the default entry point is index.html, so it's fine. So this is the thing that it has generated. Now the main page doesn't contain anything because we didn't give it anything. But since we gave source and include folder paths, it has tried to do something with this. So in the file list, at least, it has picked up the solver.hpp. It has gone through the code, tried to understand what are the functions, what are the arguments, and so on, and listed them. So by default, you already have a skeleton of our documentation. Now, the thing is, it's okay, it looks nice or sort of nice, legacy nice, but you want to start writing a bit more descriptive explanations about what does init do, what are the parameters, what do this TBC, tbulk parameters mean, and so on. So let's start doing that. So what you'll do is, let me stay inside doc so that I can keep recompiling every time I make changes. So we'll document the init function. That's the simpler one. So the way you document it is, this is the standard C plus or C and C++ comment, multi-line comment, right? Like this, the compiler will just ignore. So Doxygen basically utilizes this only or exploits this only to create comments or explanations. So if you write something, this is a human-friendly explanation for what init means. If you write this and just do Doxygen doxy file again, I will recompile or reparse the code. And now if you just refresh this, see, this has come here now. Okay, so like this, and you can also link to the code. Like it tells you it's in line number 19 of solver.cpp. You can stop. If you don't want to link your code to the documentation, you can disable this, but this gives a nice thing. And if you hover over things, it will also give you little definitions and go back to the, you have to enable this, yeah. So init file. So you can go back and forth between your code and your explanation in a nicer way. And the nice thing is, if you read the code here, the comment doesn't show up. So it's a clean, pure code, no comments here. So if you really want to clean up your code files and keep your comments separate and your code separate, then you can just, well, in the source file, the two will be there. But if you want to see only the code part, you can go to Doxygen and see it. It strips off all the comments and shows you this thing. Many of the editors also nowadays do it, but yeah, this is one way of doing it. So now the thing is, you might not just want to write a single line or just a huge paragraph and leave it at that. You might want to explain slowly what are the constituent parts of your code. So again, let's go back to solver.cp. Usually the few things that people recommend you write is, one is a brief description, which is like a one-line summary of what the thing does. Initializes given array, 2D array, given temperatures or whatever, Vulkan to Vulkan. Here's the brief. And at brief means basically that is the abstract kind of thing. Now comes the description. Okay. Or you can just leave it like this. Like without anything, it's basically the main description or the main text and so on. So you can write your whole essay here when, I don't know who, whatever, Fourier was working on maths, he did not know. So then what you can do is, you can actually, if you're doing it properly, let's do it properly. What you can do next is, you can also document the parameters. So there are 3 parameters here, TBC, Tbulk, temp. What you can do is param TBC, then you say what this does. So this is the boundary condition temperature. This is param Tbulk, is the bulk temperature. This returns nothing, so you can leave it as it is, or returns none, or something like that. So this is the way you comment things. You can add comments here. By the way, one important thing, I don't know if you've noticed this or not, I did not use a single, like the standard multi-line comment. I used another extra star after it. So this is what tells Doxygen that this is a Doxygen comment, not a usual C++ comment. If I did something like this, Doxygen would not pick it up. Okay, because it says, oh, it's just a standard C++ comment, nothing to do for me here. Only if you put a double star at the beginning instead of a single star of a multi-line comment, then only it will pick it up. Or the other way is, if you don't want to write a multi-line comment syntax, just you want to write a single brief summary. So this is like you'll, instead of a single line comment, you'll put an extra slash. Okay, so then you can write it like this. Brief. This is something like this. Now that I've saved it, and if I go back, and if I again do Doxygen doxify, see here, see nicely now it has started documenting the. So here you'll get the summary, and if you go to more, then you'll get the actual big ones. Okay, and here you can now see it has a thing called parameters, where it's nicely separated out the parameters and their meanings and so on. And returns is none or void, you can say. And whatever was your summary that gets repeated, all this you can modify, like whether you want the summary to be repeated and all those things. You can even theme your HTML in a very different way with different color schemes and different placement of windows and so on. Okay. So basically, this is the idea of Doxygen.
Sir, I had a very basic question actually. Sir, how did you integrate HTML and Doxygen? Like HTML is just a markup language. I'm not aware about web development, so I asked.
See, Doxygen will generate the comments that you wrote and what do you say? Decorate them with all these fancy things and generate the HTML for you.
Okay.
Okay. You don't have to do any HTML writing. Okay.
Okay. So it's just easing our task for.
Yeah.
Okay.
Yeah. Okay. And The other thing is, well, if you want to do something in HTML and CSS, you can. Doxygen gives you the opportunity to theme your HTML in different ways. So generate HTML is yes, HTML file extension. So you can put your custom header, footer, and all those things. Style sheet, which is CSS, to basically theme your. If you don't like the blue and white color scheme, you can change it completely.
Okay.
So this is the default theme that people usually use. So we usually go with this only. So this is the basic idea. So now the thing is, whenever you write code, if you feel like you need to explain something, instead of a comment, you can think about writing a Doxygen comment. That way, whatever small notes you're making, that can be automatically compiled into a documentation. Okay, and then there are like a fancier stuff where you can enable some portions of your comments only for developer internal reference and only some portions for external user reference. So for example, you don't need your clients to understand which version of FAQ you're using and things like that, unless they really want to. So those will go into the developer reference, not the user guide. Okay, things like that. So again, those all options are here in this Doxy file. There are at least some 300 different options you have. You can try to go through this, or you can go to Doxygen's manual and go through the list of documenting the code. So it'll tell you exactly what all to do here. Means it's a summary of what all options are available. Usually brief, normal, or add description, and params and returns is mostly what you need. That's all. You can add to-dos, you can add code snippets inside the comment. Then you can add small write-ups also. So I'll just show the write-up part once, because that is a bit non-trivial, and Doxygen doesn't explain that very well. I don't think they'll explain it here. Last I checked, it was not there. So what I mean by write-up is, for example, you can see the main page here. Oh, by the way, so apart from these file lists, you can create a list of classes and a code browser and things like that. So let me quickly generate that also and show you, because just this doesn't look very nice. There's a search bar also you automatically get. So for example, if I want to search for init, it should give me init. This is very useful.
Somebody we just
Actually,
broke off for like 2 minutes.
Yeah, it says my internet connection is unstable. Hello.
Hello. Yeah.
Hello. Yeah.
Yeah,
Are you able to listen to me?
Yes. Yes.
Okay.
Yeah.
No, it said my internet connection is unstable.
Hello.
In between there was.
Oh, in between there was something. Wow. Okay. Something happened at this time. 10:29. Okay. Now it's fine. Recently poor. Sad. Okay. Now it's fine, right?
Yeah, it's fine. Yeah.
Now it's fine. Okay. Fine.
There is a breakage now again.
So, Bangalore's Wi-Fi side has started sucking so bad. Wait, I'll rejoin. Let's see. So only if I present my screen, the thing is lagging, is it? When I'm talking, it's not lagging. Huh?
Yeah.
Bad
Looks like
problem. Maybe I should upgrade my plan to 500 Mbps or something. Because when they say 500, they give you 50.
Yeah.
So, okay. So just again, let me know whenever I break off, then I'll rejoin. This is sad.
Yeah.
So, okay. So what I was saying was that in the default documentation that we generated, there is only a main page and files, but Doxygen can list a lot of other things, like classes, the functions, and small essays that you write separately as tutorials, and all those. So let me just quickly show you how to do those things, because that will be a bit helpful. Just listing classes and comments won't be that, because it is useful, but not that useful also. I'll quickly go to my. Yeah, just give me a minute. There's so many. By the way, if you have any doubt, you can go through this. I'll tell you why there's a separate small file like this. Okay, essentially, see, Doxygen gives you this by default generated configuration file, right? Now, instead of trying to go in and modify, if you want to programmatically create the configuration itself, then you can just forget about this. You can, so I'll remove the configuration file and the full listing. So clean, no documentation right now. It's full clean. I'll generate the default file. This is doxy file. So it had all the default values like my project and so on. To make it customized to my thing, instead of writing it here, I can just go to the end and append all my options there. Overwrite the previous options. So project name, I can again write here and call it Python percent. And so on. And then input path is and so on. So that way you don't need to go through this entire, some 2,500 lines of options and try to figure out where to change and so on. You can remember what all options you want to change and just add them and overwrite them at the last end of the file. Or if you don't even want to touch this default configuration file, then just forget about this. You can create a small patch outside, say myconf. Okay. By the way, this is the INI or IN format that someone was mentioning, right? 2 sessions ago, they wanted to know about INI when we were bringing up the Python script thing. So this is an example of an INI file actually. Okay. So you can put project name is equal to my thermal solver. Interesting. It doesn't recognize IN. So okay. So then include path would be src. And if you want, you can go to the code library and see what all usual comments people use. So project number, input paths. Forget about this add things here. These come from CMake. It's not necessary right now. You can directly put the paths. It's fine. Okay. And internal docs is yes. Because basically whatever portions of the comments you mark as internal only, it will put those in this version of document. If you say no, it will not put. So usually for the user documentation, you don't put the internal documentation portions. For the developer guides, internal developer guides, you will put it as yes. So let's just skip it by default, whatever it is. Recursive or output directory is again, wherever you want your output documentation to go to. By default, it will go into build/html in the same folder. Recursive would be you try to find out all the commented source code files in folders and in the folders given in input path and their subfolders as well. So this is usually always yes, because no one nowadays writes a single library with a single folder, or if it's a very small library, you can write it like that. So yes, and then generate tree view. So we'll see what is generate tree view. Okay, so let's quickly generate the file with these only. We'll see what it looks like. So you have a patch like this. What you can do is you can cat your conf into doxy file. Okay, so it will basically add the contents of this customized INI file into at the end of the doxy file. So now your doxy file is customized to your needs without even touching it. So now if you run Doxygen on this doxy file, let's see what it generates. Okay, so on the left side, you can see something. It's not populated yet, but something is there. Okay, we'll see what comes in here in a bit. I think we already saw here, right? What comes there? Oh, they don't have that. Okay. So apart from this, you also have options like have dot basically allows you to generate those dot files which are used for viewing the dependency graphs, the images, diagrams that you saw. Extract all is again, as I said, like if you don't explicitly comment on make a Doxygen comment on a particular function, it will still extract some rudimentary function signatures and I'll create a default documentation for it. So usually that is useful if you don't like documenting code yourself. So
Somideep, that HTML link opened automatically for you, huh? When
oh
you...
no, I have to open it.
Okay,
It was already open. I just refreshed the page.
Oh, that's what. Okay, that's okay. No, I thought after running it'll open that. Okay.
Oh no, it's not that smart. Actually, it's see, there's no guarantee you'll have a browser installed. No.
That's true. Yeah.
So okay, we usually don't want to generate LaTeX, but if you want, you can. Okay, we'll see also how LaTeX looks like generate. And if you want to use MathJax syntax, like LaTeX syntax, inside Doxygen it comments itself, you can enable MathJax. And it will allow you to write in LaTeX format also. So we will try one example like that, because that's something people like. People have used LaTeX like in everything. Like even for nowadays, almost every...
Will it include text figures also?
Figures you have to create by yourself. No, see, Tix is not tech. Tix is not tech.
Oh,
It's a separate library. So it's a extra dependency. So it's it conforms to the tech syntax, but it's not part of tech. So
no, just wondering.
This is a nice project. You can take it up. You can create a open source software which does that. It'll be actually useful, especially for research community. They'll love tech. Okay, so this is the extended Doxy pipe that we have. I think it will append overlappend, but it doesn't matter. But let's take out the redundancy. It doesn't matter because the last one is the latest one is the one which is taken by Doxygen. So we'll again call Doxygen. Now I'll go and open it. So let me open from the browser command line itself. So from HTML index. For some reason, it's not picking up. What did I do? Extract all. Yes. Oh, if you don't. So, just 1 minute. Let's clean up the build folder once because it seems to have. Misplaced my yeah, this looks fine. What is it we have? We had project version and that's it, right? Oh, not include path, it's called input path. That's why it's not picking up anything. See, this is the problem. Bug in config files also. What to do? Life is only like that. So you can go to index.html. Also, oh, I didn't do this thing. Is it? I didn't push it. Okay. It's normal thing, but still. Oh, by the way, so you can see that loading MathJax going on here. That is fine. But again, why is it not? It's not called input path, is it? That is the mistake. Called input. in all these steps that I am doing continuously, you can automate using CMake also. So CMake allows you to write small shell functions inside itself. So when you're building your test cases, you can also build your Doxygen internally in CMake itself. But that's not necessary. You can put this whole cat myconf thing and doxyfile thing in your GitLab ci.yaml. We'll do that to automatically automate the build process. But let's quickly do it locally once before things become bad. Yeah, now it's back. Okay, so file list and all is here, and then extract classes and all. There will be options. So basically, if you have classes, it will show classes. Currently, our code doesn't have classes, that's why it's not showing anything. So there are multiple options. You can customize your documentation as you wish using all these things, and generate preview. Let's just enable that once. So the order of these options don't matter, so you can place it anywhere, but usually if you have a particular location preference, it becomes conditioned. Okay, so basically this is like your file explorer, file browser window thing. So it'll show you the file list. If you had classes, it'll also show you the list of classes. It assumes you're doing object-oriented programming. That's why it doesn't show functions, global functions listed separately by default, because in Java and in a proper object-oriented C, you don't have global functions. Every function is a member of some class. Classes are global, not functions, and so on. But here in file members, you have functions.
So Medeep, how do you include in comments equations and all?
Yeah. So we have I think it is this weird syntax. Just 1 minute. Yeah, okay, /f. So.
Okay, Samir. Yeah, fine. Like, I just wanted to know if you can add it.
Yeah, so let's try once. Like
yeah, sure.
Instead of just, I think this escaping is required because $symbol is by default in a comment. It means some dollar itself. So the escape character is /f. Should work. Doesn't work. Shame. Did it? Nice.
Oh, okay.
Yeah,
thanks.
And if you want to include pictures, that is also important. So where is include pictures, including graphs and diagrams. Yeah. Achha, by the way, as you can see right now, it is not, I think, generating the dependency. It is. Okay, by default generated. So dependencies are usually generated inside header files because those are the files which contain the signature of the functions and so on. But I think you can enable, if you put half dot, it will also enable for individual functions also. So let's do that. So usually then you will be able to get an overview of what the code dependency looks like and see how dirty or how simple or linear your code is. So half dot, basically dot, these are called dot files which generate, which are required for these diagram formats. Yes. Yes, I think so. Let me not be. So you can do a Doxygen thing. Now in your source, yeah, see, nicely your source is included. Include, and this, everything will have this thing going on. So it will show what are libraries you're including. It's a bit helpful. So you can imagine what the dependencies look like in a big project. So let's go quickly to EKGS. Here's a document, so-called documentation. I'm not that heartless. If you go to suppose classes and go to STL holder, for example. Oh, I haven't included those things. Oh, fine. Fine. Next time I'll include those file dependencies. Class hierarchy. I think that's where it is. Ah, yes. Separately. So you can see nicely what includes what includes what.
Oh, this is very nice, man. Actually,
Yeah.
So yeah.
Okay. So you can have a lot of things here. That's what I'm saying. Like if you want,
Sir, is there any way we can access these pages of the?
it is public. You don't have access to this URL, is it? Means okay. This depends on what VPN you're using. Actually, are you on a Windows, Mac, or Linux system?
Linux.
Okay, yeah, that will be a problem. Our IT support team prefers Windows. That's why they have configured everything for Windows. They don't, surprisingly, they don't like Linux. Fine, we'll. So basically nothing. You have to go to 40 client and download 40 clients on this thing instead of using the embedded VPN that we usually tell you to do. If you just go to 40 client and download their proprietary thing. So the one which is embedded in the this thing, it's called Open40 SSH or something it's called. That's an open source version of the same thing. But if you go here and just download the free version of 40 client VPN and install the depth file if you're on Ubuntu, RPM if you're on
Got it,
CentOS,
sir. Yeah.
okay, and use this. If you want to use this, okay, fine. We will post the method for this. I'll post the method for this in systems. So systems repo. I'll post this in. So if you do that, then all these PKGS, SSP, and code, all this will come automatically. You don't have to add etc hosts for these things. Other configurations you have to. Okay.
Okay.
Yeah, we were here. So you have namespaces. One thing. Class list, class hierarchy, class index also like this, class members. Okay, fine. So what I'll do is, if you want to create a documentation like this or even better than this is not actually a very good documentation. It should have more things. If you want to create comments like this or like standalone pages like this, then you can use Markdown or restructured text or Doxygen's .docs file itself. If you, how to do that is, suppose I want to I want to reuse the README as the front page. This README that I have, I just want to reuse it as the front page of my documentation itself. Then Doxygen actually gives you a by default easy way to do it. For other pages, you have to do a bit of file path setting. But if in your myconf ini, you just say that use MD file as home page or something it's called. Use MD file as main page, and then you give the path of your MD file. So here, relative, it will be .md. So now I think if you compile again, this will come up. Oh God, this is bad. What mistake did I make? It's called readme.md, right? Yeah, it's called readme. Oh, yeah. There is one more subtle thing which has to be included. Where is this thing? I think it needs input path also for the same thing. Yeah. So docs public. Yeah. Okay. So in your input path, you have to place this as well. Otherwise, it doesn't. Only if it is your reference files are in the input path, only then it will take it. The small pitfalls that Doxygen has. It's running the graph files also. You'll see a lot of graphs. So it's reusing the MD file as the main page, and then now you have classes and all coming in. Okay. it has started documenting our catch include header also. So you can exclude these things as well because this is not needed per se. Okay, so this is roughly what Doxygen is. And if you want to include other pages also, then there's a simple way to do it. Let me again quickly refer to my documentation. Keep confusing between this and yeah. So if you want to suppose write an essay, okay, like my solver or something. So this basic markdown syntax that you use in your readmes and all. So if you want to place this as a separate, write-up or a tutorial or example and so on, then again in your Doxygen setup, you can just put this in the input folder itself. So there'll be a dot here. This is a bit risky. So that's why you usually segregate your internal documentation or standalone documentation files into a something like, notes or something like that if you want. So move your MD files or notes into this. And then you can put in your my config ANI. Include notes as well. And you have to somehow, you have to link it, but let's quickly try once if it works out normally. Otherwise, only if you link it to an existing page, then it will show up. Otherwise, it won't show up as a standalone page, I think. The page you usually link it to is the main page. No, but it shows up. Yeah, okay. So you can have a list of custom tutorials or something here. And you can nest them also. If you want to nest them, you can go to Stack Overflow and search for how to nest them. You might find a familiar answer there. So this is it for Doxygen. There's a lot you can go into, but there's no point in doing a generic thing. Like, no need to cover it here. It's very case specific. Okay. Sphinx is very similar, except Sphinx, the theming is a bit better. So Sphinx is what this is like. This is a standard format in which Sphinx generates documentation if you use something called read the docs theme. The other standards are Alabaster and things like that. So as you can see, this looks fancier. You can use Sphinx the same way, almost the same way, except okay, fine. Let's generate a Sphinx thing. The usefulness of Sphinx is, apart from the nicer looking interface, is that Sphinx will automatically extract all the inline comments that you put in your Python functions and classes. So as you know, if you're writing a Python file, so like test.py, and you're defining a function, like define my foo or something, then you can actually write inline comments using a multi-line comment like this. Like this adds two functions. This is the standard way you do it in Python. So if you just write a code like this and run Sphinx on this code, it will automatically extract all the comments, inline comments from here, and make a documentation out of it. Also, you can add extra pages like using restructured text, that is their choice, instead of Markdown or Doxy file. But it's very similar. So you'll again have to do pip install Sphinx or something it's called. Again, you'll have to generate a configuration file, run the configuration file on your source code base, and it will generate HTML, LaTeX, and all this. By the way, we didn't see how the LaTeX file looks for Doxygen. Let's look at it once. So I think it will be called, let's do a grep. So many PDFs. Shortest name wala PDF. No, nothing. Should be called something standard. How do you find which is the Anyway, if you find it, you can see it. We'll skip it for now. Okay, so this was documentation. Since we have come this far, let's just put it in the automated pipeline that will sort of clear our heads. So usually you don't commit the actual documentation in your code. So one thing is you'll have to do a git ignore on the HTML and the LaTeX files that are being built. Otherwise, if you look at your git ignore file as it is right now, you already are ignoring error.out, obj, and all this. Build is one directory. When you put a directory name like this, any directory name build that is occurring anywhere recursively in the whole repository will be ignored. Okay, so just take care of that a bit. If you want to ignore only the root build directory, so what we can do is we can utilize this fact. And someone wants to say something. What you can do is it will be nice if you can put this LaTeX and HTML output inside a build directory of its own. You can do that in your myconfig ini, saying that my input are those parts. My output directory is something it's called. Yeah, directory is build. It will generate the HTML and the LaTeX inside the build directory. So again, if I do my config ini, docs file, print, see. As you can see, there's a build directory inside which you have your HTML LaTeX. The outside ones are the old ones. So we'll remove them. And now, we'll run the test by ourselves. And we'll name it this a bit better. So we'll call it our config.ini. That's it. Now, if you do a git status, you'll see that we're going to add doxy file, the conf.ini, the notes, and the index. And so we modified server.cp with the comments, so that is also going to be added. Push it. Now, what we want to do is we want to automatically do all these documentation building whenever we are packaging the code and send it to the client also. So like we learned yesterday, you go over here, you say that one of the stages is this. So maybe you want to build the documentation parallelly and not depend on a particular stage, like test or build. So you can say that in the build stage itself, you can build the documentation. So you have a plain code build, and now we will do documentation. Build documentation. Here, the stage build. So you will essentially do what we were doing inside the, like manually. So go into docs, and so one thing is whenever your virtual machine and that custom OS is being booted, you're always dropped into the root folder root home, and the repository is cloned directly to that root folder home. So the place where you start off is basically the root of your repository itself. So that's why you can just go into docs by CD. You don't have to search for any path /home/etc or anything like that. Okay. So CD docs, and then you can do your doxy cat conf.ini, your doxy file. And you can run Doxygen. Now there will be a problem when I push this one now. What will be the problem? Can someone tell me? This would have been my what? Sorry. That this path will include docs/build, right? Because that is where the thing is we can include a HTML also. We'll ignore the LaTeX. Huh? So we'll directly include HTML. .html we'll call it. Okay. And then when we are packaging the stuff, we will include this documentation as well. So we will put this job as a dependency on our package for who wants documentation for this solver. Let's say the pro client wants. The mini client anyway is running an executable. So what we'll do is we'll say need job build documentation. Facts. Artifact that we are sending off is this path itself. Like it won't bring the HTML into the root folder. It will actually just copy this entire path. So the artifacts will insert the other stage will also look like docs build HTML. So what we will do is we will copy our docs build HTML into thermal pro / we'll call it doc itself. HTML. So when you open the documentation, we'll see how to do it. That's it. We will now. Can someone tell me what will be the problem here? There will be if I push this, it'll throw an error. The runner will throw an error. It's because in the code, this image that we had built, there is no Doxygen installed. Okay, so now we have to go into our Docker file. This is a good recap of what Docker files and all those are. Sorry. Yeah. We go into our Docker file, edit it, and do this is the magic. Since we are going to reuse most of the layers, we don't need to do a install from scratch. It will only install Doxygen on top of the already existing layers. Okay. So we'll again go to our repository and those steps that we usually follow. If someone remembers it, they can do it directly. I don't usually remember half the commands. So do login, and then the second command is we'll build the image in the name of this, the thermal builder, as from last time. Oh, we need to be giving the folder where this Docker file is. As you can see, it reused the initial layers very quickly, and it's only installing Doxygen on top of it and updating the image, your custom OS image. Yeah, my internet connection sucks.
Samideep, is wine also something like this? Like similar philosophies? Or is it different?
No, it's different. It's actually
Okay.
a bit different. What happened? Oh, okay. I thought that red line is an error. Okay, fine. Successfully built. We'll push it. Layer exists already on this remote server. That's why it won't push the existing layers. It'll push only the extra layer. No. Doxygen itself is 155 MB. Can you believe it? People have no respect for space nowadays.
Why it's so big?
That's what I'm saying. People code as if they have enough hard disk space, RAM space. Like at what? If you spoke to the early developers of that Macintosh and all, they would have like started crying looking at 155 GB for a documentation. 155 MB, sorry. Yeah.
No, that too, this Doxygen is very old.
Yeah.
You know.
They would have added some fancy things nowadays. I don't know. Well, these new age people keep adding.
Millennials.
Maybe they put ML something here. Anyway. So yeah, now that we have the image ready, now we can safely push this. So we modified our CI pipeline, modified our Docker image. Just now that we have the image correct, I really hope this doesn't fail anywhere, because I vaguely remember it kept failing last time we were doing this camp at this stage itself. It took me half an hour to figure out where it failed. So I want to be extra cautious this time. Okay. Doesn't let it fail. What will I do? It failed. It failed. Build doc in CI. Okay. Let's hope for the best. Sorry, pipelines. Pending. What happened here? Something failed. Six minutes ago. Why? Package from mini client failed. At what? This will fail. God. I forgot to delete. I deleted that index.md, the earlier MD docs document that we had, and it's trying to search for it there. Our mini client. See, we were giving a nice document to our mini client. What we'll do is, instead of this, we'll give them the readme itself. Deal with it. So this will be a fix doc packaging. You had asked me about change logs, right? I think this would be a nice place to just talk a bit about how you automatically generate change logs. So let's just confirm that it has gone online. The other one has failed, but oh, it's still running. This hasn't failed yet. This is supposed to fail, right? Okay, the others are passing. So this would be a nice place to talk about. There's this thing called Angular. Angular is basically a web framework for automatically generating front-end pages. They have a big coding team, and they do a lot of commits, apparently, using Git, some Git thing. And they came up with this convention called Angular conventional commits. So what it says is, when you are writing a commit message or a summary, you, instead of just writing the summary, you prefix it with a category or a tag of a one word or a abbreviated tag of what this kind of thing for category it falls into. For example, this is a fix, okay, a bug fix. So you can either call it bug or you can call it fix. Don't call it bug because the act is actually fixing it. So let's call it fix. So doc packaging, things like this. When you're writing a new feature, you call it feat or feature and so on. Then when you're writing a test or testing something, call it test. If you're just not changing any feature, adding functionality or making any text or fixing any bug, you're just refactoring the code. It means just making it nicer and so on. Functionality is going to be the same, just call it refactor, like this. So now, later on, in your Git log, when you just, if you do all these, so next time we'll do this, you start using these kind of conventional commits. When you now do a Git log and just grep for, this is not the correct way, if you just do a one line kind of thing. This is the syntax. Yeah, then you can just list the tags between any two, between the last release and this release, and grep for all these keywords like fix, refactor, test, and categorize what all fixes are included. Refactor is usually not included in the change log because that is a irrelevant thing for the end user. It's just internal coding consistency and all those things. Features is one, so you'll grep on feat, you'll grep on fix, and you'll, what else? What else do you do usually? So that you can, if you're changing some build step or changing something in CMake, you can prefix it with build and so on. Or if you're doing change in CI script or any of these GitLab pipelines, you can prefix it with CI.
So this is just a agreed upon convention.
Yes,
for,
yeah.
So this is what the name can be anything, no? Actually, I mean.
Yeah. So usually the
just a name.
Yeah. So usually the tags we follow, at least I follow, is again, it's, if you don't remember something, always go to one of these repos. It's all noted down here. Using GitLab. There will be something called conventional comments of conventional. Yeah, these are the tags I use. So you have feed, fix, docs, style, refactor, perf is for performance change, test, and chore. Chore I usually don't use because it's a very generic thing. And if you can't figure out an exact keyword, you'll end up using 90% of your comments will end up being a chore. Okay. So try consciously not to use this. Instead, you can try to add one more tag that is not falling into any of these categories. For example, build and CI are two things which I prefer for build tools and CI. That is not in here. Okay. If you want, I can list it down exclusive here itself directly, but yeah. Okay. So get back to our pipeline and see if it worked or not. It passed. Oh, great. Hopefully this is the one that passed, right? So if we go to the package for mini and we download it, we'll get our mini client package. And if we download our package for pro client, we'll download our pro client package. Now let's open them up. Bring it into desk. Everything code related comes to desk. So zip, unzip. To mini client. You have the README as expected. Okay. And in the pro client, you have the docs. If I open the docs and go to index, where's index? Nice. There's the documentation that has been packaged into the thing. Now, if you want to add one last step to this entire pipeline of packaging, so you're doing automated tests, you're running the build, you're generating the package, and you're packaging it with the documentation itself. As I sent a mail yesterday that everyone now can host their own static web pages or any folders in PKGS. So what you can do is you can go into any of the NIS machines that are available to you. So I'll just remove these things for now. You can go into any of the NIS machines. So if you go to the user guide, you'll have your list of IPs here, shared machines. And suppose I want to go into Rachana ID. This is the IP. I have the SSH key copy ID done already. So if you go into G data out, you'll see these things. So try to, this is not what, yeah, try to go into packages. And here you'll see these things. These are basically the official repos, so don't touch these. You can create your own home folder. So let me call it. And just when you're creating a home folder inside packages, use your username. Otherwise, IT people might think it's a random package folder somewhere publicly hosted and they'll delete it. If you just use the same username for the folder that your NIS username is. And so that other people can't modify your folder, just do a chmod. 700 is the most restrictive, but this is a public thing, so give at least read permission. So I think 55 is the name of the thing. So if you do ls-l, you can see others can read and execute. Execute doesn't mean anything for a folder, but okay. Read and execute, but they can't write anything to your folder. Okay. So this is if I now put a package here, suppose I call it abc.txt, something. And now if you go to PKGS, again, as I said, just if you're not getting it directly, one thing you can do is you can modify your etc host if you're on Linux. or you can download that proprietary 40 client and use that. It'll automatically come. You can add PKGS inside this as the IP of PKGS is 200. Okay. So 172.16.1.200 pkgs.synchroslabs.com. If you add, then you'll be able to go to pkgs.synchroslabs.com. So where is it? It was somewhere. Okay. If I just go back to the packages. Here I have my newly created folder. As you can see, 11.17. I guess that is today. If I go in, the text file I created is here. So you can put any text file, any files that you want. If you put an HTML file, it will render as a web page. And that is how we are rendering our web pages also right now. So if you just put a HTML, okay, let's say, and that is exactly how the documentation web pages are rendered here. So if you go into SS Labs and HPC Sim and the core, by the way, everyone is done with the CSERT, right? Then I can remove it later on. Latest, if you go to doc, essentially the doc that I give to the two pro client, thermal pro client, that HTML file, I've just hosted it here and it's rendering as that document directly in the web here. So you can host your own documentation and or websites and so on. Our new company website is also hosted here internally for review if you want to check it out by the list. Okay, things like that. It's very this thing. It's still a work in progress, but if you want, you can check. Okay. So,
Samit, why did you ask us? Why did you tell that we can create our own folder in that PKGS? As in, like, if we have our own packages or something like that, like library.
Or if you want to have your own blogspot or something like that. Anything.
Oh, if you want to create. Okay, got it.
I'm not by default creating everyone's IDs here because I don't know if someone wants to publicly share anything or not. If they want, they have the permissions to create. Yeah.
Okay, cool. Okay.
I mean, the permissions in the Linux permissions. Permissions anyway, everyone else.
Yeah.
Okay. So yeah, so we'll just do this. We'll deploy the package once. Actually, leave that unless if you really want to deploy your package automatically from CI into this, that's a separate topic. It'll require exchange of a certain number of public keys, which I can't show on screen right now. Okay, I can if I hide my screen for some time and so on, but it's complicated. It's not complicated. It's just hassle to turn off and on the screen and so on. Okay, so I think we are covered with the process flow part. By the way, if you have been hearing this buzzword called DevOps, this is what DevOps is. Plus few database and things like that. That is not necessary. So now you people are all certified DevOps engineers. So if you want to go join Amazon or Facebook or Google, you can see I am a DevOps engineer. Give me.
I see only terminal.
Okay. Basically, if you know what is going on inside this this kind of thing, pipeline, each of the stages, you know what DevOps is. Okay. Basically, DevOps people build these kind of tools to help. DevOps basically expands to development operations. So anything that helps developers do their job is DevOps. So we have till now helped the coder in us. Now we will become the coder in us. Okay, which will bring us to optimization, parallelization, and whatever sizations are there, vectorization, and all those things. So 11:30, we are doing fine. But anyway, this was not in the topic for today. We just took some time to. Atif, did you expect to this time to be wasted of yours like this on documentation?
It's very interesting.
No man, I didn't know this. Yeah, I never used this like this.
Yeah. Okay.
And Swami, so whatever you said yesterday about having the base code and going through all the procedure, to package it for the client and all that. So that is handled by a few set of people in a company, right? That's like, it's not like all of us.
It is handled by a few set of people because they were the only people who were trained in the last session. That is why this
okay,
training,
okay.
so that we can
Okay.
distribute the task more and more, because there is
Right.
so much dearth or scarcity of such people, DevOps engineers. Now that we have a whole team of DevOps engineers, everyone can build a package by themselves.
But give to whom?
That's okay.
That's what to say. Like client bringing and all that is not my department, sir. You bring the client, I'll take care.
Hey, sorry, man, you broke off. I didn't hear what you said.
Nothing. There's good effect.
Okay. Nothing important.
Okay, fine. So we'll just git push, and we're done with the git push. So we'll just merge this back in our thing and clean out the repo. So I think logically here would be a logical place to stop, but since we are still 1 hour away from the official break, let me just give you a brief introduction to the things that are going to come up in the next half. By the way, this is again the place where we do code review. Since all of us has been reviewing the code for the last 1.5 hours, I'm merging it. Fine. So when you merge, it will now try to run the pipeline on the main file, its main branch, it's the current state of the main branch. So it's only main now, and it's running. So let it run for some time. If you want to see the dependencies, this is how it looks. Very nice, ideal. By the way, the tests are coming, and okay. So any questions? So basically, if suppose now you go back to your daily work and someone says, just DevOps this project, will you be able to do that? I need a verbal confirmation from everyone, because this is what the certificate issuing depends on.
I think yes for the small projects like this thermal one.
No, so that's the thing. So basically, see, if the code increases, the DevOps part won't increase actually. This is going to be the same steps. See, even for code,
Yeah.
I have the same DevOps steps.
Yeah.
Yeah, hopefully.
No, I meant only in terms of the unit test. Yeah, rest of the things, yes, we can.
Unit test what? Instead of 10 unit tests, you'll have 1,000. Yeah, that's all. And that's why I got so many runners. No, I'm waiting for you people to start writing unit tests and running so many like tests like this. 100,000s. See, right now we have 2 runners. What to do? But if it increases, we'll scale out. We'll use Kubernetes and all those things. Fancy terms we'll use. Fine. Okay. So let's look at what is left. CMake packaging and all, I'm not doing because that is a bit complicated. So I'm just skipping that part. It was definitely not going to get finished in this 25-minute time period. It would have taken at least 3-4 hours. Now, after the break, what we'll do is how to speed up a finite difference code. So the idea is the thermal code that we wrote. There's a reason why I was writing this code, because this will be the basis of our OpenMP and MPI implementation and optimizations and so on. Okay. So I'll check out the main, and this branch which is hanging around, we'll delete that. As we saw before, hanging branches are headaches. And this package was sh. What is it? Has no purpose right now. We should delete it in the next comment or something. Yeah. So right now the state of our code, actual code, is this. Oh, by the way, there'll be garbage in the docs. Where did our... Oh, okay. Yeah. I got scared. Where did our Doxygen files go?
Samit, so if you do git branch minus a, it will still show all those.
Yeah, so basically the folders which you have ignored, which are not in the purview of Git just keeps them in the same. Like even if you change the branch, it will stay. So you just RM, like delete those. So,
Okay.
if you want to delete. Basically, Git says, look, I have not version controlled this. So if I delete this myself, user will get angry that I had important stuff there. Why did you delete it? Without asking me.
Okay.
So it keeps it. So yeah, we have this. Now the state of our code is it's still small in the concept. Now comes the meat of the code, so which is the solver library. and we have the init. There's nothing to do with. We'll start with theoretical estimates, huh? Because to speed up a finite difference code, okay. Just can someone tell me what are the changes that you would make in this whole for the update step? It's so simple. It's like I shouldn't even talk about it. Otherwise, people will beat me up. How good is it logic to write 2D or 3D array in this syntax? Why do we even do malloc and all those things? Why just not write something like this so it's simple? And so on. So if people are clear with these kind of questions and answers, then I'll just skip over that part and go right to the theoretical estimate, the bandwidth and compute estimations and flops and all those things. But if someone wants a quick recap of why we do malloc and linear arrays instead of this nice cuter syntax, I can go a bit into it.
Yes, Amitip, like this for 2 minutes. I know roughly, but
Okay.
I would like to know what you mean.
Okay, fine. So let's do it by example. Let's get by the compiler and then we'll get to know why we do it. So if we change here, no, then okay, let's fine. We'll change. We'll take the pain of changing because if you want to optimize, you'll anyway have to do this. So the idea is this is a cute syntax, and we'll start optimizing right away. So the first step of optimization is time your code. By optimization, we usually mean optimizing for wall time. No one cares about, as we discussed, no one cares about space anymore because people are full of RAM and hard drives and things like that. So before we do anything new, we always create an issue out of it. Because otherwise, why are we doing things? There should be a reason behind this. No, okay. Increase. I'll write something. Don't worry about what this means. Oh. Check out to 9. Okay. So the first thing is, okay, by the way, is everyone here familiar with C++? That's the first thing, even before all these array and all those business. Like, is there anyone who would want an explanation for what the hell even this is? I can quickly go into that also. Because if that is clear, only then the next steps will be clear. Otherwise, it will be confusion layered on top of confusion.
It's fair to assume that.
Anyone who doesn't want to speak up because they're feeling very shy, you can just ping me personally in the Google chat also.
Share your chat screen while they think.
I'm watching on the phone. Fine. Your privacy is guaranteed. Who said this? Wait, what? Oh, achha. By the way, general question till people type in the chat. Did you all fill this dipstick survey, workplace survey?
Yeah, I feel.
Yeah,
No.
I did.
Yeah, me too.
What did you say about, I'm feeling optimistic about the future?
I mean, strongly
Strongly.
Is
agree.
it anonymous or non?
We should create a group in which all the answers somebody does records the answer and it just tells the answer so that everybody can fill it.
See, Dominic, this video will not be seen by top management, right?
They are in the list. Madhushri is sharing it with them.
Hey, remove this portion. Previous 15 seconds.
Okay, fine. I don't think. Salva might see, I don't know. So, okay, fine. So no one has pinged me on my chat. So I'm assuming that people are comfortable with the syntax as it is till now. Okay. So the thing is, now suppose the first thing, okay, let's time it once. How do you time code? So usually in C++, you have that chrono thing. Or you can write your own timer using that sys_time functionality. We'll use S3 chrono. Let's close all this DevOps stuff. We are done with DevOps for now. Oh shit, let's close this also. commit message. Okay. So the standard reference for C++ is CPP reference. We used for precision last time. There will be something called chrono library in C++, which will work right out of the box. And it has also an example, so you can just copy paste that example. So whatever function you want to time, just above and below, the first thing is hash include the chrono library. So then this is the function they're trying to time. So above that is start and below that will be stop timer. So we will time, see, usually we time only the performance critical part of the code, which is basically the part which is being repeated a lot of times. Init is just done once, so we'll skip that. And the end part is this elapsed time. For the people who think that you have to remember everything, as you can see, real development is mostly copy paste. Okay. The actual development actually goes on in your head, the ideas, the implementations are copy paste usually, because code patterns keep repeating. That's why there's a whole area of research called design patterns. So we'll time this. How do you compile? This is the problem with doing CI. We have removed any option of compiling it ourselves locally. Sad. Okay, fine. We'll create a compile script. Oh no! What am I saying? We have CMake. आसान नहीं है बाबू. Oh, there's a unit test thing. But it's very important, unit tests. Yeah, now it will come into play. Why unit tests are very important. Because in the fervor of optimizing your code, you will do optimizations which will break the physics. Then you will basically get a 10 times higher speed up, but your physics will be wrong. That is the worst thing that can happen to anybody. And I'm pretty sure it has happened multiple times to multiple people.
Even for just simple O3, they give that caution, no?
O-fast. Huh? O3 is deterministic. O-fast is the one which does the funny business.
Oh.
So O-fast basically ignores commutativity of real number arithmetic. Yeah. That commutation relation is a very sacred thing if you're doing chaos theory. So, yeah.
We lost it for, I think, few seconds.
Oh, okay. Huh. Now it's fine.
Yeah, now it's fine.
Okay, so we have our build, and let's go and time it. So we can run it directly here. Build.
So we're saying something about O-fast. Is
Okay. So basically, O-fast ignores the commutativity of real number arithmetic. So it says that x into y is the same as y into x, which is usually not true in discrete mathematics because you have that precision limitation. So overflow, the rounding off of x into y can be different from the rounding off of y into x. So you're basically doing quantum mechanics at a like mathematics level on a real, if you're using real numbers. So it's not commutative, but O-fast assumes it is commutative because they assume, mathematically the assumption is that the overflow is in the order of epsilon, which is the machine precision, 10 to the power minus 16, and that can be set to 0. That is the assumption it makes, and that assumption can break any code that tries to compute any nonlinear dynamics problem, and especially if you have divergent Lyapunov experiments.
Sir, I had one doubt. What does this O3 and O-fast flags do in the backend to speed up our codes?
Okay. We'll come to that. Yeah, we'll come to that. So you got a time of 10 to the power minus 5, which is ridiculous because I think mostly the timers here themselves are in the order of milliseconds or something. We can see what it is, or something it will be. 10 to the power minus 5 is not a very good time resolution. Usually when you're benchmarking your code, it's best to bring the time to the order of 1 second at least. So we will, what to do? We'll just, our test case that we're timing, we will increase the number of iterations or increase the system size. We'll come to that. So src app cpp. 10 to the 5, right? So okay, we'll multiply by 10 to the 5. Maybe 2 seconds, hopefully. Then again, build. 0.138. Something changed. 80. This is because, well, this is not wrong technically. What it basically means is that our 12 by 12 system we have been running for 10 to the power 5 time steps with a traditional boundary condition of 80. In 10 to the power 5 time steps, everything is thermalized to or equilibrated to 80 degrees, 80 Kelvin. So this is technically not wrong. What we can now do is we can try to proportionately increase the system size also and bring it back to the original value of 262.008 that we were getting. So to do that, what we will need to do is near app.cpp. What we'll do is okay. So is the scaling clear to everyone that when you in a 2D problem when you make this 24, means 12 into 2, effectively you have increased 2 points, twice the number of points on the x-axis, twice the number of points on the y-axis. So it becomes 4 times the system size. So it will take 4 times more memory and all those things. That is clear, right, to everyone? Then we'll quickly skip over this hard-coded numbers and go directly into hash define nx 12, and we'll use these first. We're soon tired of using these hard-coded numbers. And for this, you'll also need to change the stuff outside because I think in the solver library, we are hard-coding 12. We have to define hash define here also, and now we'll have a conflict problem, like which NX do you take from where? So the best way to do things like this is to define a configuration file itself. So usually what you'll do is in your include, you'll create a config.hpp and all the constants that you are using, these constants, you will use them here, define them here. So define your NX to be 12 here. And everywhere you hash include this config.hpp. I know it's not as elegant as just defining it in the source itself, but this will solve a lot of problems, trust me. So now we have our first. By the way, we promised ourselves that we will not use hash pragma once unless we find a need to do so. So we'll delete that hash pragma once. Let's see where things start failing. So here, this. What the easiest way to find out where all changes have to be made is you just do a f minus r for 12. Oh, I'm a genius. I forgot about actual numbers of 12 also. So let's name it. So here you will again, this will take a bit of time. If you want, you can go take a break for 2 minutes and come back. But this is important because now that we are going to keep changing system sizes and times and all those, it's best if we take care of this properly. Otherwise, unit tests will fail and then timings will go off and then we'll be confused as to what happened.
Okay, init
Sir, have
temperature
you
also
defined NX globally? Because in static array, they give bugs sometimes.
Oh, what do you mean defined globally?
Means एकदम ऊपर code के define NX something.
Yeah. Huh?
So if you don't do that, it gives bugs. Like I'm not sure, but I've
He's
seen
included
this.
that, no? In that include.
Acha, okay.
Include config, I think he has spelled.
Then that's
Yeah, here. Since, okay.
Yes.
So,
Soumyadeep, these initialization temperatures also you can.
see, this is a test case. Huh? So if I put 80, it should come as 80. That is fine. Because I'm not going to generalize the BC temperature here. See, that is part of the library. Like that feature of making it modifiable is part of the utility, flexibility of the library. NX right now is a constant because, by the way, we are doing hash define. We are not passing NX as a variable also because that is one of the limitations of using a static array like this, because this won't take a variable. This will also have to be compiled time static number. So we'll come to that. Once we start using dynamic arrays, we'll make it a flexible variable, runtime variable. But let me just quickly refactor. This is an example of refactoring. So here also we'll chuck this hash define. We'll do an include. Tests are done, right? Yeah. Tests are done and includes are done. Solver HPP. Oh, we have to include this here. Yeah, otherwise we would get to the next one. And source. This is the main place. So we'll again include. By the way, why is this solver in double quotes? So double quotes usually means, okay, let's leave this. You can use double quotes or bracket quotes. Try to use angular brackets. Try to avoid double quotes unless the file is in the same folder. But later on, I'm pretty sure you'll get into some circular dependency problem, and then we'll discuss where it is used and where it's not. So point.hp. And I'll just as long as you put that -i path, double brackets and angular brackets mean the same thing. It's not an issue. If I was using VS Code, I would have just searched for 12 and replaced everything. Even I can do it right now. Yeah, I don't think there's another 12 here. So we'll do a 12 replace with NX globally. Done. And this 11 business we will replace with NX minus 1. 1 remains 1. If you're writing a library, usually 1 will be hard-coded as min and 0 will become min. What is it? Min padded or something like that. Forgotten my own libraries. Okay, fine. So here we are. Now, if we just try to do a quick compile of these things, doesn't fail, huh? Oh, that's great. And if I run it, interesting. So it compiled. I'm still pretty sure it is going to break somewhere, but okay. Assuming I've done everything correctly, let's go back to the problem we were trying to do. So the idea is, how do we increase the time? One is you can increase the number of iterations, but then you're seeing that your reference value is just becoming the boundary condition Dirichlet value. So there's not much scope of doing a physics test per se, because everything in the end will equivalent to the same temperature, nothing to do. So let's decrease the iterations, but keep increasing the size. That also will increase your time. So we'll go to our include config. And increase it to, first of all, okay, how much can you increase it to? The memory that is being taken up by your array is the 2D array, so nx into nx. So right now it's 12 into 12 elements. Each element is of type double. A double is 8 bytes. So 12 into 12 into double, 8. So that would be 144 into 8, which is, I don't know what is it? 144 into 8 is 1.1k bytes, so 1.1 KB essentially, right? And yeah, and then you have 2 of those, so you'll essentially end up having 2.3 KB of memory being allocated. That is fine. That is not too much at all. Now, usually you shouldn't allocate more than what is available on the system. And how do you see how much memory is available on the system? You just do a minus. If you're in Linux system, free minus G. This will show you how much memory you have in GB total of RAM. How much is used? 4 GB is used. Free is 6. So I can go up to 6 GB of allocation on the RAM. When you do these kind of allocations, they always happen on the RAM. They don't allocate on the hard drive. So if you want to allocate on hard drive, you have to explicitly call something like a file IO, OF stream or IO stream, OF stream basically. Yeah. Okay. So whenever you create variables and arrays, they always go into the RAM of things, and the RAM size is given by this. If you want your hard drive size, you can go to your system utilities, or if you really want to do command line wise, you can go to fdisk minus.
Sir, sorry, could you please repeat? Actually, I was lost because of that network.
Yeah,
What is the
sometimes
size
it
of
breaks,
RAM?
maybe.
Again, it's breaking, huh?
It is breaking.
Wait, again, I'll be there. Just give me 1 minute.
Yeah.
We'll do a quick check, synchronization. I'm audible, right?
Yes, sir.
A,
Yeah.
C, D, E. Right?
Yeah. Okay.
Okay, fine. So we were what we were discussing is that whenever you create an array like this, it is always allocated in the RAM, not the hard drive or anywhere else. And how do you see how much RAM space you have? You either open up your laptop and see how many RAM sticks you have installed, or by software way you can just do free -G and the next system. Or if you have Windows, that whole system, what visualizer, I don't know.
Sir, I had doubt in this command last time you told me to run it. So this swap, what is swap memory or what is swap in short?
Okay. So in short, swap is extra RAM that is created out of your hard drive.
Acha, okay.
Okay. If you want a slightly longer version or a more legible version, basically, if you have only 16 GB of RAM and some software or application requires 17 or 18 GB of RAM, to fit it or to give it a bit more space instead of dumping it fully into hard drive and or giving a segmentation port, what the OS will do is it will create a small extra portion of your hard drive. It will earmark as a extra RAM or a slower RAM or a virtual RAM kind of thing. So that
but then how it gets decided, like कब use करना है
that completely your OS decides. You can't decide that as of now.
Okay.
Unless you write your own OS.
Okay.
So again, the buffer cache and all those things. This cache is not the processor cache, by the way. This is a very common mistake people make. This cache is basically the cache that is there on your RAM, which is temporarily storing. So suppose you're going to write a file. You're opening gedit and you're typing something, just so that the temporary, or like for example, I have opened up this file, right? Like this Vim.
You just broke off, Samadhi. Just what you said.
Oh, okay. Okay.
Sorry.
Oh, yeah, sure.
I think
no,
I'll switch on captions, man. Captions won't also work, no? If that happens.
No, might not.
Hey,
Yeah.
actually, I was able to hear him continuously.
Didn't break for us.
Yeah,
Oh, maybe my internet. Okay, sorry.
Yeah.
Are you in Bangalore?
Yeah.
Same.
So Soumyadeep has been restarting for other people's network issues also.
Okay.
Yeah, catch me.
So, yeah. So, suppose you have opened this Vim file, right? Now, if the Vim file was actually whatever you're modifying, adding, deleting, and so on, characters, if everything was happening between the processor and the hard drive, it would have been very, very slow. Like you would have typed something and there would be a 1 second lag between when it actually appears on screen. Because the hard drive read-write speed is slow in comparison to, for example, RAM, 10 times slower actually. So usually if your RAM 1, we'll come to all those things. What is the RAM speed? What is the hard drive speed?
So it's like a buffer for this file.
Yes. So basically, temporarily, your application, which in the end will be stored in the hard drive, temporarily it is cached inside the RAM itself, just to speed it up a bit. Okay. If there is RAM space, if there is no RAM space left, yes, it has to come directly from the hard drive and so on. So this is a philosophy that you'll keep encountering multiple times across layers of the hardware architecture in a computing system, that you always cache only if there is cache available. If there is no cache available, you pay the penalty of a long distance drive. Okay. So this cache is basically the cache between on the RAM for the hard drive. There will be another cache in the processor for the RAM that you can't access or program as of now. There have been discussions with Intel and AMD about building a so-called scratch pad instead of a cache, where you get to program the cache itself. But if you get to program the cache, then it will cost you a lot, because the actual processor cache is a very delicate and a very fast and obviously very expensive piece of hardware. There are companies which are building entire computers based on cache itself. They don't have RAM or hard drives. They are extremely fast. You buy one computer, that single computer will be 15 petabyte per second of bandwidth it will give you. But they cost, I think currently it costs $500 million. No, not 500. $500,000, yeah, or 2 million, something between 0.5 and $2 million. So if you have that much amount of money to spend, you can buy one of those Cerebras 2s. Okay. So anyway, that was a long segue. We'll come to that sometime maybe. We were here trying to figure out how to increase the system size. Okay, and we were discussing how much can we increase the system size to, and we calculated that right now it is 2.5 KB, 2.3 KB. And if we increase it, and how much RAM do I have left? 6 GB. So I can happily increase it to some certain amount. How much will be NX if I have to increase it to 6 GB? Let's just keep increasing. We'll see where it fails. Let's say it is. So 10,000 into 1,000 will be million, right? As if you're saying something.
No, it'll probably fail at 1,000, I think. Maybe.
Let's see.
Let's see.
Oh, this failed for something else. No. Wait, see, something changed. It says cannot convert double 12 to, so somewhere there's a hard-coded double 12. Where?
So this time we need to use double pointer like previous one you used.
Pointer as in? Oh, acha, you were saying. Okay. Wait. We'll come to that. Well, no. Why? Just changing the size. Just by changing the size.
Yeah, sorry.
Why would you say?
You are still on static array, no? Then that should not be the case. Sorry.
Yeah. Now it should work. Okay. So we run it. Oh God, segmentation fault. What?
Stack Overflow, right?
Stack Overflow. Stack Overflow usually gives a different. Oh, this is Stack Overflow, is it? Oh,
Yeah, I used to get this on lab computers.
Oh, okay. I know this. Okay. So what Atif is mentioning, something called Stack Overflow. Okay, no, first of all, what is the segmentation fault? First of all, segmentation fault means there's some problem with your memory. Ideally, very experienced or senior software or older software developers will tell you the moment you get a segmentation fault, don't try to second guess, run a debugger like GDB or run a memory leak detection tool like Valgrind. Okay, so these are tools which will become like a Docker container in between your OS and the running of the application, and it will emulate the pointer mathematics that is going on. Emulate, not run. It will not actually run your code on the hardware. It will emulate the code's interaction with the hardware. So it's 10 times slower at least than the actual run. But it will find out exactly where your pointer is going out of bounds and all those, and in the end give you a summary report of what this one line of segmentation fault actually means. It will identify exactly which line of the code it is going into. We can do that. If you want, we'll do an optional topic on that, because that is not exactly necessary, or it is actually necessary. If you talk to Santosh, he'll say that is the first thing you people should learn. I can't believe you people don't use all these things. So there is something called Valgrind, where you can run. Should we just run our code on this once just to check? Actually, let's do it. Fine. Let's do it. For that, again, I remember the Valgrind command. Oh, by the way, you can just install Valgrind using sudo apt-get install Valgrind. So equals memcheck. So it can check memory, it can check cache also. So we'll not do a cache check right now. Memcheck. And what is your app? Build app. I think this is a command. I might be wrong. See, it's this is how it generates a report. So you have to basically go through it. It says Stack Overflow. Atif, 100 out of 100. Correct answers. So it says Stack Overflow in thread 1. So anyway, it's a serial code, so it's saying thread 1. Then it starts saying, if you believe this happened as a result of Stack Overflow in your program, you can try to recreate these things and figure out what, or go on reading. Essentially, it means Stack Overflow. Now, what is a Stack Overflow? So usually, let's go to the app section of things. Usually when you're allocating any array, it will get allocated on the RAM. Now your RAM has enough space, as we saw, it has 2 GB, and this 1000 cross 1000 will be hardly a few MBs. So that means it is not because RAM doesn't have enough space. RAM has enough space. It is some other problem. The problem is that when you have static variables defined like this, like the static array, they are usually allocated to a portion of the RAM which the OS reserves for the program code itself, instead of what the program considers as data. So there's this differentiation between what are program instructions and what is program data. So for example, 8010, then the string called elapsed time and the string called you got A, all are data because they technically are not part of the instructions in the underlying the processor, or they are not part of the primitive instructions in the compiler also. Okay? So these are all considered as data. What are like actual instructions and things? Addition, subtraction, then allocation of memory. This what type of allocation? So dynamic allocation, static allocation. We'll come to those dynamic and static allocation, things like that. So these kind of internal things or system level things, if you call it, not system level, program level instructions, they go into a portion of the RAM which is exclusively dedicated to instructions or program codes. So that portion of the RAM is called a stack. The other portion, the data part, is called a heap. There are some small other portions, we'll not go into, roughly the stack and heap. Now, usually what the compiler or the OS will do is it will assume that your program is not an infinite program, because obviously then you can't load it into RAM first of all. It also assumes that the program is a certain size, maybe 100 MB. Your this app file, the size of that is 4K, okay, 4 GB. So it usually assumes 1 MB, 2 MB, 100 MB, some maximum size. Again, these are system defaults which you can change and all those things. Okay, there's some default size. So it will allocate only that much. When the program launches, the OS will allocate that much to the program. Suppose 1 MB it allocates to the program space or the memory address space that the program or code can use, the instruction portion of the code can use. And remaining portion of the RAM, it will allocate to whatever data you want to store. Okay, you want to write a 1 GB file, you can write. But the writing instructions, those will be going into the 1 MB thing. Now, when you define static arrays, they eat up into the stack portion of the code. Okay, so when your stack portion of the code exceeds a certain size, it overflows. Basically, there is no more stack space left, and that is called a stack overflow. Okay, that is where that website gets its name from also. So now, okay. So basically what do we do? One is to reduce the system's size again, but for a real life problem, you can't help. You have to simulate bigger systems. So that the first thing you do is you convert this into a dynamic memory. That is why you use dynamic memories. That's the main reason. Okay, because sometimes if your array is small enough, you should actually use stack, because it is much easier for compilers or the processor to figure out that a stack data or like variables in a stack array, it's much easier for the compiler to fetch to cache, processor cache in real time, because it knows already the limit of the stack or the limit of the, the size of the array. For a dynamically allocated array, the size of the array is not coded into the definition of the array itself. So that's why if you have very small arrays like 12 by 12 or 16 by 16 or 8 by 8, you can use stack, not an issue. It will hardly be a few bytes, so it will fit into stack. It won't stack overflow. But for anything more than 1 MB, or even I would say 1 KB, go for dynamic arrays. Dynamic arrays are what? Instead of doing a double A100, you do C++, forget malloc for now. Double star A is new of double 100. And the only other caveat is when you create a static array, so this is the static array, this is the dynamic array. These are different from the static and shared libraries that we talked about yesterday. but that's why some of the other nomenclatures for shared library is also dynamic library or a DLL. Okay. So dynamically loaded library or something like that. Linker, something there. So dynamic arrays, when you define, you have to do the management of the allocation and deallocation on the RAM. Because once you use dynamic arrays, it goes into real time runtime allocation. So the compiler cannot pre-decide where to allocate and where to free. You have to explicitly free when you're done using this array. So you call delete this array once you're done, something like that at the end of the code, or whenever you're done using it and so on. So we'll use this syntax for
Yeah, I have a
allocating.
question.
Yeah.
Is stack access faster than caches, L1, L2, L3, all of them, or?
So the thing is this: stack stack resides on the RAM. Okay, it's not like whatever you define as a static array will automatically go to cache. The only thing is that stack. The reason why you need to use compile time constants, like you can't give a variable like nx and take this nx. Okay, there are two things. I'll come to your question in two steps. Before we go into this cache business, one of the key features of one of the difference between static and dynamic array is this: where does it get allocated, heap or stack? The other part is that you cannot use a runtime variable to initialize the size of your static array. So runtime variables mean like anything that you get during the running of the program. Either when the program is running, you read from a file a value, or you pass as a command line argument. Okay. So suppose I said that my first input parameter during the run should be the size of the array. So I call this int nx is TOI. I think I need to include something, but okay, let's see. What is it? CST lib, is it? I think so. CPP reference. ARGB1. So this is the first argument that you give from the command line. Let's do that actually. But it will test when everyone knows this. It's like too trivial. So you can't use this here. It has to be a hard-coded value, either directly or through a hash-defined pragma. Okay, like we are using nx, capital NX. So that is one limitation. You need to know the size at compile time. So basically, the developer who is writing the code, when they're compiling the package, that time itself they need to know the system size, and that is the only system size it can run. Okay. So that's why you don't use static arrays for the grid sizes of a simulation itself, because grid sizes can change depending on the resolution you want and all those things. What you can use it for is basically if you're simulating electromagnetism, which has 3 components of electric field and 3 components of magnetic field, then you can put a E3 and a B3 here and things like that, okay, or H3 and so on. Or like if you do LP, then you can have a F of Q27 and things like that. Those are static arrays are fine, and they're small also. So now, Atif, coming to your question, static arrays, since they use this compile time constant values, the compiler already knows what is the maximum extent of the array. So it can better understand what the loop behavior or these kind of things, where the loop starts, where the loop will truncate. For dynamic or heap arrays or dynamically allocated arrays, the compiler does not know at compile time itself what the possible size of the array is. So there are a few optimizations it can't do beforehand. And because the compiler is able to do those kind of optimizations for the static array, some of those optimizations include prefetching the data into processor cache much more easily. Okay. It can predict much more easily. Okay, so although the static array is initially allocated on the RAM itself, albeit the stack section of the program, it will be prefetched to the cache most probably compared to a heap array. Okay. Again, it depends on how many times it's being accessed and all those things, but yeah. So yeah, these are the things. Now, so this is int nx. I'll be using. So it's clear to everyone, right? Like we cannot use static arrays for large grid sizes. For small things, yes, fine. For large things, So we will start using dynamic arrays. Now dynamic arrays here, should be, so technically there should be two arguments, an x and an y. For now, let's assume an x equals ny. Okay. So we will be allocating nx into nx here. And all these things now we have to reorganize, sort of. So previously we were nicely able to exploit this 2D array syntax like x bracket y. Now we will have to just deal with this linear index thing. So basically the equivalent of this would be, just finish writing this once. I'm assuming these syntaxes are familiar to everyone, so I'm quickly skipping them. If anyone has any questions regarding these, you can stop me. Or if you don't want to speak in public, then you can DM me right now, but otherwise it will be too late. So you're passing temp. We'll change the signature of the functions from static to dynamic pointers. And what else do we need to change? So the first instance of using a flat index. So this will now become a call to a flat index, which will be 1 plus nx into 1. Right? So since we'll be reusing this flat index thing quite a lot, let's just define it in a header, common header somewhere, so that we can continuously use it, or just call that continuously. So we'll call it indexing, index.hp. So I'm intentionally not using hash pragma once because I want to create an example where it fails and where we really understand why we need header guards and hash pragma ones or hash pragma ones and so on. So we'll do a inline. Let's not do inline, also leave it. No unnecessary stuff, just basic. Size T also leave it. that will actually do another segmentation call, but leave it. So this is the flat index. So flat index of index into y would just be return x plus nx. Here nx is a dynamic variable, so we have to pass it. We can't hash config add it. So in that sense, our hash config, our config.hpp is also useless right now. So we can just delete it. That way we'll know where all errors will start coming up, like compilation errors will start coming. We can fix it like that then. So when we are passing this index thing here, we will be doing index 1 1 nx. It's good. And then we will be doing a solver. So in our solver, we are going to delete config.hpp, and then here is the main meat of the changes. Since we are going to include index here, oh, by the way, we have to include index in the app also. Just let me know when it's 12:30, huh? Because I'm not able to see this time right away. It's on the screen. So once it goes into these kind of codes, really you lose track of time. DevOps people don't lose track of time. They're like, when will we finish, man? Optimization people are like, oh my god, this is nice. So, and
Pramodev, it should be capital NX.
capital NX was the static hash macro we were using, right? Now we are shifting to dynamic arrays, where we are taking the NX from command line.
Okay, okay.
So that's why I deleted the config.hpp.
So the for loop has to be changed also, right?
Yes. I'm just putting in the indices.
Okay.
Yeah, then I'll quickly, because the indices at the, oh god. Oh, if someone can parallelly code with my VM, can you please change this also? It's such a bad thing. This is why I think people who use Sublime and VS Code are cursing me. Like, औकात में आ गया. I don't know if any shortcut of changing this pattern of plus minus 1. Is there any pattern in Vim in VS Code or Sublime which will simplify this particular line change? Or is it also going to fail? Like you'll do it manually like this? I don't know.
In Sublime, it is there.
What is it? What does it do?
So you just select the portion you want to edit, then Control D finds the next instance.
See, it will find the next instance, but if there's X and X plus 1, they're not the same instances, no?
No, that it won't do.
That's the thing. No, I agree that these 3 instances of X, Y, and X, X, Y, and X, X, Y, and X can be replaced. I agree. But that is, yeah.
For X minus 1, wherever you find X minus 1, you can do
Yeah.
those things you can do.
But those will happen only there only. Yeah, but the other places where it's just X, Y, that would have been easier. Yeah. Actually, I can do it in Vim also. It's just that string replace. There's only one left. Like that phrase. No? You come to the end of Ramayana and then ask who was here as well. Okay, we're done manually doing this. Next time, please remind me to use Vim's hotkeys for this. Now NX. NX will replace with duck. But can we? Then we have to pass this NX first here. So this temp is now going to become a single dynamic array. And this is going to become NX, small nx. All the capital NX will replace with small nx using a hotkey. And this one is also going to become a yeah, that's it, I think. Yeah, okay, cool. Just ignore the background sound. Someone is selling flowers. What is this doing here? Oh, okay. This is fine. Oh, what was it? 12 comma. Cross 12. Right. This is extremely boring, I realize, but what to do? Once we get this part of the solver in shape, the remaining optimizations will follow through nicely. Not index. We need index? No, technically we need index. We are not referring to anything here. Yeah. And delete is necessary because otherwise each test will keep leaking memory. I think that should be right. Yeah. Oh God, no, it's the other thing. Okay, there's only one here. This is fine. So we're good. Else I might be missing solver.hpp. So this now becomes, oh, we have to pass this int nx now. Yeah, signatures we screwed up. And this will be starts. And what else? What else? Solver.hpp is done. Index is fine. And we have src app doesn't config. Oh my here is the main thing. NX and NX will be needed. Any other NX behavior? No. By the way, did we change this, all the solver signatures? Okay. And now the actual implementation of solvers should have NX, correct, NX. Yeah, I think we are ready to go. Test. Eight and here. Oh. Oh, okay. There's no conflict, but index. Okay, I think we're done.
Sir, even temp00 index table.
Oh yeah, thanks. You're catching bugs. Yes. I'm using it. Oh, we were using index. So heavy big data index. Just for the sake of two of these, we will use. I think these have to be escaped as special characters, maybe, I don't know. What is it? 12. What? Forget it. Those are to be escaped, okay, fine. Is it? That's it. It's escaping. Let's chuck it, like, let's do it manually. That's faster, actually.
Hello, yeah, can you come for 10 minutes? We have to get COVID rapid test because this week our vaccination hoga.
Okay.
So to be eligible for vaccination, we have to do this test.
Okay, so I'll come.
Yeah, you can just come. I have the new auditorium, where backside of your hostel.
Yeah, understood. Okay.
You can have the new
Oh.
auditorium near
Yeah.
Simple.
Okay.
Okay, finally. Oh, great. Now this is the fun part. So as you can see, it says there are multiple definitions of index int. So basically what it's saying is there's a multiple definition problem coming from test update. And then when it is trying to do test init, it is saying that there's already some index intent defined. Why is this happening? The reason is test init is calling index.hpp once. Test update is calling index.hpp once. Then in the test init is being compiled into a test init.o, like or test update.cpp.o or test init.cpp.o here. Essentially, the object files content, like this analogy is quite appropriate right now. You have seen the cartoon pictures of this cough to virus, right? This the crowns that it has and so on. So just like that, you can imagine an object file, this .o files. They have these function signatures sticking out, because any other application which wants to link to the libraries that can be generated out of these object files, it has to do this kind of a antigen antibody kind of key pair matching kind of thing. So basically it exposes its functions. Now what the problem this compiler is having while compiling the executable is that test update.cpp has already included a function signature of this type. Now separately, since it is creating a separate object file for test init also, that is also trying to include its own index int function signature. Now if these two .o files are combine it to the same executable, there will be a conflict between which same function signature should I keep. Should I keep test update.os function signature, or should I keep test init.os function signature? That's why it is always best when you're defining a function signature, you always do it once in a library. And we have done it actually. We have written index.init separately only once. But since these files are separately including the same in the header file multiple times, it's getting compiled into multiple separate versions of it. That is why you call something like, that is why you add something like header guard, which says, traditionally the header guard is written like this. If ndef, if not defined some unique string for this file. So usually people put the file name only. So it will be called index_header or index_h. If this is not already defined, then define this variable. And then do whatever you want and then ndef. So what this will do is, if I am starting running this code from scratch, suppose this is the first one which tries to include this. So there is no, I'm not defining when I'm compiling, I'm not passing that -d index_h and all those. So there is no index.h defined. That's why it will say it is actually not defined. Therefore, it will go through as a first step. It will first define that variable and then include all these other things and then come out. Now in the second step, when CMake is trying to create the init, this update.o object file, then when this index.hpp has been included, again we'll go into that index.hpp. Now we will see that index_h is already defined because the previous step defined it for us on the fly. So then it will not go into this at all and not include this at all. It will already know that my function signature has already been included somewhere. Let me not do it redundantly again. Otherwise it will lead to a conflict. So it will not include this file at all in itself. That's not a problem because that function has been defined elsewhere. That is your guarantee. When you're saying if and if this thing then define this, it's a guarantee that if you find it is already defined, you're good to go. It has been defined somewhere in your project only. Unless you, in a very evil kind of way in the compile step, you pass that -d index_h flag, then nothing will be included, but still it will be defined. Then the compiler will be like, where is this init function? Where is this index function? So please don't -d compile flag include header file guards. That is why people see, now the thing is, someone might legitimately have a variable or a macro called index_h. Then it becomes a problem. Then you have to first see, okay, what all files are being included where and so on, what are the header records and so on. That's why what people nicely came up with is, forget about all these things, forget about all this macro business. We will use a pragma or a syntax called hack pragma once, which basically does the same job, except it doesn't conflict with any macro names and so on. Any compiler that has been developed after 1980s has this. So I think you're pretty safe. So any questions here? I know it's an unnecessary segue maybe, but is the philosophy clear? Why we do this hash background once or if and if thing? In regards.
Yeah.
Okay. Yeah. Okay, thanks. Then we go back to build. Now we can build again. Hopefully there won't be a conflict. If there's a conflict, that means my no, what is the actual thing? Wait. First defined here, and then I think somewhere else also we haven't defined the header. So now we'll start putting header records everywhere because something is including something and not defining it properly. So let's see. Basically, it will be include files only. So solver.hpp might be the other one. Yeah. What is the signature of this?
But why did this error come when you did if not diff thing? Or
Why did this
you not?
error come now? Means after I included the hash pragma once.
No, did you compile after you did if not defined index?
Right.
Oh, okay, but why did this
Still
error
coming,
not come?
right?
Oh,
Just 1 minute. Test underscore. Wait, let me just. Sometimes it happens that this build folders have memory of the other previous ones. Just 1 minute. Let me verify once. This is some other thing, most probably. This doesn't mean the this error doesn't mean that header cards are useless. It means there's
No,
some
of course not.
So yeah, CMake. Was it that? Just that? No. Okay, so it was. Oh no, it is actually not that. It's some real other problem. So it says thermal.a solver.cpp. Let's see. Just give me 1 minute. Let me check one small thing. This is fine. This is fine. Okay, this brings me to the second point. Very good. This is actually a very good error. And this is the place where multiple that I'm seeing currently that we are using are failing. That can someone tell me what this error is? It has something to do with, okay, I'll just replay the error once. It's there. It's actually a very good thing because it takes a bit of time to figure out what this error is. But if you do it, you'll see that this basically motivates the usage of libraries. Because if you want to write your entire code in a single step, technically you can. The moment you start breaking files, you have to take care of a library format. Otherwise, you'll start getting these kind of errors. I'll tell you exactly why there should be a difference between a .h and a CPP file. Why not just use a header-only library? What is the problem? Like, when can you use a header-only library and when can you not? This error has to do with that. So, any suggestions, comments, what it might be? Otherwise, I'll go directly to the debugging part. So, okay, fine. The problem is that index.hpp is a function which I've defined in the HPP file itself. Again, as the same logic goes, what we did with the hash pragma once, now it is being included once, but it is being seen multiple times by each of these .o files. As I said, no, the function signatures are being seen and so on. But technically, not only the function signatures are being seen multiple times, the definitions themselves are also being seen multiple times in this case. Essentially, what you have to do is whenever you have a function like this, a global function, you should only define it in the header file. Don't implement it in the header file. Otherwise, there will be a conflict. If multiple .o files or multiple files are trying to include it at the same time and build their own libraries, and then you're compiling the libraries into executable later on. So whenever you find global functions like this in your header file, just leave it as sorry. Keep your definition like this, and then what you do is in your SRC, you create a corresponding .cpp file to implement it actually.
Yeah, so many I didn't understand. So even if like multiple .o files see that definition, what is the problem? I mean,
you can have only one definition with the same function signature, because otherwise, see, it's like I'm making multiple copies of the same function. See, compiler doesn't understand that technically they're the same. Compiler will see that if the definition is being the same and the implementation is also, if the definition is the same and it is implemented multiple times, it means I have a confusion. Which implementation should I take? Okay. See,
but isn't there any like file-wise address that gets assigned?
No, because the problem is when you compile, finally you compile your .os into a library. No? So suppose this index.hpp was called in some libthermal.a, it was compiled into, and separately it was also compiled into suppose libfluid.a. Now in your multiphysics solver, you're going to like link both libraries. Both of them will be exposing the same function, but the compiler doesn't do all this analysis. That function basically tries to do the same thing. It won't do all this. Like in contrast with what people expect, machine learning is not that smart nowadays. It might be later on, but it's not. Right now, things are pretty much if-else conditions and pretty dumb for if-else loops. Okay, conditions. So compilers won't be able to understand that these two functions are effectively the same function. That effectively it doesn't understand. I see the same signature. I see both are implemented. I don't even go to the implementation. It means there's a conflict. I'm going to throw an error. So what you do is you just define. You can define multiple times. You can declare. Multiple times. You can define only one time. Okay, sorry. There's a difference between these two words. I shouldn't confuse between those two. Declare means you declare only the signature, like this.
Okay.
And define or implement means this. You actually implement, flesh out the body or what it does.
So you basically declare it once and define it multiple times. You said.
No, ulta. I declare it multiple times. I can declare it once and include that declaration multiple times. But the definition should be there only once. Previously, I was defining it in the header file itself. So basically, whoever is including the header file is sort of seeing a almost independent definition.
Okay.
So what I have to do is basically I have to create a auto file separately for this index function. And so on. So just let me quickly finish this, then we'll compile and we'll first verify if my explanation is correct, because that keeps happening nowadays apparently. That what I say, I want to show that it got fixed and then some new error comes up. In like accusing the old answer. Index.cp. Now that we have done this, as you know, we are using CMake lists, which require you to add something in the library. So we'll add this in the library. This is how your library starts growing. Slowly. Yes, I see. Sorry. So I'm pretty sure now it will go fine. Unless there is another type of error. This error should be taken care of now. Beautiful. So is this clear? Otherwise, I can give another example to paraphrase it or rephrase it and maybe make it clear. But is it okay? Like whatever explanation I gave, was it? Did it make sense? Okay. So basically, the idea is that whenever you see yourself writing a global function, just define it. Don't define it in HPP. Just declare it. So whenever I'm using this term wrongly, just immediately catch me, otherwise this error will propagate. Whenever you're trying to define a function, don't define it in HPP or implement it in HPP. Just declare the signature in HPP and actually implement or define it in CPP. That's the best way to handle things. Otherwise, you'll go into errors you never know where it will come out and express itself as. The only exception to this rule are templates. If you have a template function, suppose you had something like this, then you can implement it here itself, not an issue. Because template itself is a template is an abstract concept. So even if multiple source files are including this same HPP file and seeing this this text, this piece of code here, it will still think of it as an abstract, undefined problem. The definition of a template actually comes at the last stage of the translation unit. Okay, so template functions you can define in your HPP. That is why you can define a header-only library if all your global functions are templated. If even one function is non-templated, like what we have indexed here, you cannot build a header-only library. Okay. So this is how it goes. Now we are good. So many segues we took, I forgot what was the main motivation of this. Always to get branch and figure out what the issue was. Dynamic arrays, we're using it. We can actually close this now. We'll just quickly micro benchmark it a bit, what the timing is. And yeah, just run the timing. Let's see. By the way, what is the size we give? Segmentation fault. Why can someone tell me quickly? This is the most common segmentation fault people get. Okay, fine. Don't guess, as great coders say. And check. Invalid read of size 1, str2ol. It basically means that my ATOI is throwing an error because I did not, my source had I was expecting a command line argument along with the binary name, but it did not get. By the way, is everyone familiar with why this is 1? Why not 0? See indices array start at 0, right? So usually the argv0 contains the name of the file itself, the name of your binary itself. So basically, if you actually print out hello from string, gv0, you'll see then hopefully see the name of the binary, which is app. So we'll pass the size of 12 first. See, hello from ./build that was argv0. And we have this. If we now start increasing the size, the time for 12 is this, because we are running only 10 iterations. We are back to 2062.008, which is a very good sign. By the way, are our test codes passing? There are not issues with tests, right? Always do a check of your tests. Oh, great. Code is clean. Perfect. Now the performance part. So we'll run with, how much will you run with? 1000? 2D, no, okay. 2D is fine. 0.5, great. Let's do 2000. How did it scale? When we doubled the x direction, the total number of points increased 2 into 2, 4 times. Did it scale 4 times? Yes, it took almost 4 times. Little bit, but okay, that much of noise is there in all things. And you got the reference temperature correct. Okay. So this is basics of, so by the way, this thing that we are doing, increasing the system size with the hardware remaining the same, actually it's not called anything, it's called stupid scaling. I was going to say strong case scaling and weak scaling and all those, but yeah, this is not an example of anything useful. If I increase it into 2 times, did it scale properly? So 2.36 into 4, that is, it's slowing down a bit, right? It's not exactly, this is not 4 times of this is more than 4 times of this, right?
Yeah, around 5 closer to.
So if I go back, it is not because my RAM is going into swap, because I have enough RAM. And what 4000 is what, 16 MB into 8 bytes. So 32 into, yeah, 64 MB. Nah, nothing. 64 MB is a very interesting number actually. So we'll see. So this is 64 MB. Previously it was by 4, or each array was 32 MB by 4, 8 MB.
How much is your cache? Oh, just 6.
Yeah. So basically it's that only. So previously my whole array was fitting inside cache. Now it's slowly starting to get outside of cache. Portions of it can be prefetched to cache. Almost maybe more than half of it is being prefetched. But okay, we'll come into that slowly, how these numbers are scaling now. So 4000 is this. Now basically most of it is outside the cache, because if cache is 6 MB, okay, for people who are like not very familiar with the hardware, now is a good time to look at what is this doing. Now is a good time to actually look at what this cache, RAM and all this business is. The best thing is to actually, ideally, if you were in the office, we could have taken out a server, opened it up and dissected it like that lab rat.
Oh man, that'll be nice.
No, so that is the best way to learn.
Yeah. To
take
see.
a few RAM sticks and processes.
Yeah.
So, but in the absence of that, let's just search for a motherboard image on. So let's see what is a good image. Okay, let's go with this super micro. The Asus nice fancy looking motherboards. These ones very nice.
Liquid cooled.
These ones won't be. These are desktop level stuff. Okay, some desktops are more liquid cooled. Yeah. Okay, let's see if. Well, I won't be able to show you cache, but I'll just show you what the architecture is, and then it'll make a bit more sense of what we are talking about. If you have a Raspberry Pi or Arduino, you can easily see that this architecture. Okay, let's go with this one. This is what Intel something. Okay. So, what a bad. resolution. Okay, fine. It at least have the required components. This is the slot where you put the processor. The processor basically looks like this. Intel. Basically this chunk of block inside which you have transistors. By the way, this is a good point to do a pitch of another repo. If you really want to go into all these things in a non-boring voice and random chaotic structure, if you really want a good documentary style thing, you can go into, I think this is open only. It is, oh, it's a log project. So what I will do is I'll make it open. Fine. Okay, so you can go into the issues and there's a huge list of, wait. Oh, sorry, this is Radhika's repo. I'm very sorry, Radhika. I keep calling so many repos as HPC training. Sorry, I'm very sorry. So all the confidential stuff will get leaked. Before that, quickly save settings. Sorry, wait, I'll go
There
through.
is nothing confidential.
No, you can have military level secrets and stuff. That's possible. Oh, it's open only. Yeah, you can see it. So delete license. Why? Oh, this was an example. So you can see this general introduction list of videos. So these are basically YouTube links. No, mostly not text. It's all videos. So you can chill on a weekend and binge watch instead of Netflix. You can watch all these. So these are like a history of computing and then semiconductor transistors, the basic, what are the computer parts, programming languages, basics of them, starting from basic up to C++, JavaScript, and all those. And then there are some courses starting from Feynman to more contemporary computer science experts and so on, and a bit of optimization and a bit of introduction to compilers. Okay, these are all at a very general level. These are not, apart from the courses, maybe the other videos are more like documentaries and nice chill watch. You can relax and watch it. Okay, so you can go into that. You can also check out the other issues which are open in PMPS and vectorization, but we'll cover them in the coding camp itself. So if you want the full path, it is this code. This is, I'll paste it in this chat. There's an open repo and you can make full use of it. If you want, you can add issues also. If you want something to be included or some topic to be like listed. Okay. Coming back to the pictures. This is the motherboard. The processor goes into the slot. In that sense, in the repo, you will find, I think, assembling your own desktop PC. One such video will give you a lot of information or feel about what all components you have to buy and put together. And 2-3 videos like this you see, and you come to the office, one server you break, you're set basically. Your hands are all matured on server grade stuff. So there's a slot onto which the processor goes. This processor has these PCB-based links called PCI. PCB is the printed circuit board, the green one you see in the background. There are links which go onto these blue lines. So these blue lines are actually not lines. These are like slots into which you place something called RAM DIMMs. So RAM DIMMs look like this. These are like 1 GB, 8 GB, 16 GB sticks. And you basically plug them into vertically into those blue slots that you are seeing. Yeah, the slots look like this sort of, yeah. Or you can open your, don't open your laptop. If you have a desktop, you can easily see it. Here, like this. So that slot, it will go vertically into it. Oh, there are nice animation figures here. Okay. The speed at which data is transferred between the RAM stick and the processor is called the memory bandwidth. And that is determined by the speed of the PCI link that is connecting the RAM stick to the processor. So as you can understand now, processor is a separate unit, the RAM is a separate unit. You can buy them separately, they can be separate companies, they don't need to have any prior relationship to each other, except that the processor should be able to take in the rate at which, or the clock cycles at which the RAM is throwing data. Now, what does that mean? This clock cycle business might throw you off a bit. Essentially what it means is each RAM stick has these pins which go down, like these yellow things that you're seeing. Each RAM stick will be pushing out, depending on if it's a DDR4 RAM, which means double data rate, it will be pushing out 2 parallel streams of data, each stream containing 8 bytes or 64 bits. So if there are 2 parallel streams of 8 bytes, effectively there are 16 bytes coming out every cycle. Now, how many cycles are there depends on the clock, internal clock of the RAM itself. I don't know if your quartz clock and so on, it keeps, whenever you power it up or even sometimes not power it up, it internally keeps refreshing. So anyway, it doesn't matter. Some clock frequency is there, which is keeping a tab of time internally in the RAM. Usually the clock's speeds are 1300 megahertz. So 1.3 billion cycles per second. It will throw out data at. There are 2 streams like that. So effectively you will have 2 into 8 bytes into 1.3 gigahertz. So 1.3 billion such things per second. So your total memory bandwidth will be 2 into 8 into 1.3. So that is 2.6 into 8, whatever that is. 19, is it? 2.6 into 8. 20.8. Okay. So 20.8 gigabytes per second is the memory bandwidth, which is the rate at which data is getting transferred between your RAM and your processor. Usually when you look up your RAM specification, I can show you something on my machine. You won't be able to see it randomly like this. You either have to look at the make of your processor, which is LSCPU. You can go and search for this online. This frequency is different. Please don't look at this frequency right now. This is a different thing altogether. You can search for it. If it's Intel product, go to arcintel.com and you will find that here it says the memory types that are supported are DDR4, 2133 and DDR3 and others. So these are DDR3 are third generation, older generation of RAMs. DDR4 is double data rate 4, operating at 2133. Now this 2133 is not the clock cycle that I was talking about. I talked about some 1.3 gigahertz or 1300 megahertz, right? This is basically the number of transfers that are happening per second. So what is this number? This is basically the clock cycle multiplied by the number of data streams that are there. For a DDR RAM, which is double data rate, there are 2 data streams. So 2 into the number of clock cycles is this number, 2133, which means essentially the internal clock cycle of this RAM card is 2133 by 2, whatever that number is, 10 something, 1060 or 70. Okay. So anyway, so essentially what it says is, okay, now let's do a memory bandwidth calculation for this. We have a DDR4 with 2133 million transfers happening per second. Each transfer transfers 8 bytes of data or 64 bits of data, like a double variable transfers. Okay. And there are basically essentially 2133 million doubles being transferred per second. So what is the data bandwidth then? So you'll have 2133 or 2.1 billion or giga into 8, which is 17. 17.0. So 17 gigabytes per second should be your bandwidth. Now here it says max memory bandwidth is 34. Why is it 34? Why not 17? As you can see here, it says maximum number of memory channels this processor supports is 2. So if you go back to the diagram here, this processor will be able to connect to 2 different RAM sticks at a given time. So basically, apart from there, each RAM being itself a double data rate RAM or double data stream, if you put in 2 RAM sticks now in your motherboard, the processor will be able to simultaneously get data from both the RAMs. So it's effectively you'll have one DDR4 2133, another DDR4 2133. So 2 memory channels, and that is why you'll get 17 plus 17, 34 Gbps. Okay, this is how you analyze. So this is the maximum memory bandwidth or data transfer rate between RAM and processor that your machine will support, that your processor will support. You can happily, if you have a motherboard with 4 slots instead of 2, you can try to plug in as many number of 4, 8, 16, as many number of RAM sticks your motherboard supports. But if your processor has only 2 memory channels, it will only give you a maximum of that 34 gigabytes per second. So But you will see that some vendors or some manufacturers place 4 RAM sticks into 4 slots just because there are 4 slots in the motherboard. Okay. Whereas the processor supports 2 memory channels. Usually, either they don't know what they're doing, which is mostly the case for desktop local like suppliers. You have to explicitly shout at them, please stop doing this. Please give me a big RAM, but only place as many RAM sticks as there are memory channels. Don't. Or the other reason is for enterprise applications. I think Dhairashil, this is what we were talking the first day before the first session started. For database like enterprise applications where memory bandwidth is not the issue, the memory storage size is the issue. Like they want TBs of RAM on a particular node. They don't care about memory bandwidth because it's anyway a single thread application. They can't parallelize it and so on. So they would want 1 TB, 2 TB, and so on. So as many slots are there, they will try to put as many RAM sticks just to increase memory, not memory bandwidth. So it depends on what you're trying to optimize. Are you trying to optimize storage size or increase storage size? Are you trying to increase the performance of your code? It all depends, and that is how you customize your hardware. Most scientific codes are memory bandwidth limited, as we will come to now about theoretical estimates, but we're already heading towards 1 o'clock. Should we take a break now? And then, so this is like a nice trailer of what is going to come now. You go into very deep hardware details and also, so basically the idea is whatever timings you're seeing here, you should be able to analytically get the same timing on pen and paper. So that way you will know that you properly understand what your C++ code is doing, what your assembly level code is doing, what your hardware is trying to do. Like this combined together brings this number to you. And that is what we usually try to market as performance.
So ideally, if whatever you're saying, if everything is deterministic and everything, it should be exactly
yes,
right?
Yes. Yeah. So we will come to the cases where we will try to figure out. Well, trying to figure out noisy levels of deviation is a much more complicated task. Noise is something which statistical phases do. I have no idea about what that. Okay. So we'll try to get the ball.
Okay. Yeah.
Also, perhaps, I heard there is a C++ some kind of plugin or some .h file or something which does the flop calculations, like which tells us flop calculations.
Is it? What
is it? That's what I vaguely understood, like in discussion.
Which discussion?
A few days back we had discussion in our group. So someone was suggesting there is somebody knows about it. I think he was talking about this like flop calculation or.
See, the problem is flop calculation. Yes, you can emulate that, but you can emulate flop calculations. Plugging in a header file, I really want to see this library. That will be a genius library. Because I have no idea how to write such library. Unless you emulate it on a virtual machine, like Valgrind. Valgrind, or the equivalent of that, which is called, I keep forgetting the name of this. Okay, like Valgrind, there is a emulator on which you can run your code and it will try to figure out the operation. See, VTune is basically like that kind of thing. VTune basically gives you an intermediate middleware layer where it emulates instructions and your interaction of the code, and it tries to calculate, like store basically all the data, do data analysis on your code and so on. But because it's emulated, it is very slow. 10 times, at least 10 times slow it will be. That's why you can never benchmark a real live 20 node run. Always benchmark a small, like few MBs run. Otherwise, if you're
the readings that it gives in terms of flops, those are accurate, right? I had once used Advisor. I just wrote sample code using certain number of flops, which would give certain number of flops. And I got exact from
So basically, if it's emulated, it will be exact. Yeah. That's what I'm saying. Is this library that you include as .h file, is it an emulator?
No, I don't think like that is the case. I just vaguely understood that is this. So I was just asking you.
Okay. No, I think that's what I'm saying. If it's emulated, then yes, there are a number of such tools in the market. If it's a real-time library where it doesn't degrade your performance, still gives you flops, that is a genius level code. That is something which even AIs also can't beat. So let's. But whoever said that, can you just ping them and ask what is it?
Yeah, sure.
When we talk about memory bandwidth, do we talk about the RAM speed or the PCI bandwidth? Like, do we talk about
So
RAM
yeah,
bandwidth
yeah,
or PCI bandwidth?
So okay. That's a good question actually. So usually the
Yeah.
cable that connects your RAM to your
Yeah.
processor, this is where the motherboard also has to be compatible with your processor and your RAM.
Right.
See, if your RAM is very fast, but your PCI slot is bakwas,
Yeah.
okay? If your PCI cabling is bakwas on the motherboard, then no point. Your PCI will be the bottleneck. So usually the PCI cabling that takes in the data between the RAM and cache, that is very fast. That is not the usual normal PCI link that you usually get between, suppose, a graphics card and a processor, and so.
Right.
Okay. Actually, the link between RAM and processor, it's called something special.
Bus, I mean, they typically use
Some data bus or something it's called, yeah.
Yeah.
I keep forgetting the exact name of this. Okay. Maybe we can go into this and read up. Bus, yeah, memory bus or something it's called, yeah. Anyway, like different vendors have different names for it, but the idea I think is memory bus, yeah. Like if you go to Intel, they will not talk about memory bus. They will call it what? Ravi, what is it called? QPI or something. I don't even remember what it means nowadays. Like QPI links. Don't talk to us. Don't talk to Intel about memory bus. That is below their level of dignity. QPI is something.
And InfiniBand or intra-node connect bandwidth is generally much larger than this, or how does
It's
it
much
compare?
lower than this.
It's much lower.
Your InfiniBand or your Ethernet cabling will be maximum 1 gigabit per second or 100. Okay, InfiniBand is 100 gigabit per second, which is 100 gigabit per second is 12.5 gigabytes per second. So 12.5 gigabytes compared to, okay, let's go to Rudra. Let's find out how much RAM and bandwidth it has. So we'll do whatever we did on on India's 5th largest cluster. So we go into a node. Let's go into a node. By the way, has anyone used interactive nodes here? This is how you use interactive nodes. You just put a minus sign and submit. It'll drop you into a node for 1 hour. So you can now.
Hey, how do you set up passwordless SSH to nodes?
To nodes or to Rudra? Which one?
Like you just do SSH Rudra and then no password needed.
Okay. So you're saying this step.
Yeah, so you are saving the key somewhere here.
Yeah. So no, just do SSH. Okay. You can do it to any machine actually. SSH, copy ID. Okay, if you're not storing the username, or if your username is the same as your local laptop and Rudra, then just do Rudra, or the IP basically. So
Okay.
if you do this, it will ask your password for. Wait, I don't think this is the IP. It's ulta. It will just copy your public key into Rudra, and that's an authentication. I have already done it. That's why it said I'm skipping.
Okay. Thanks.
Sorry. I'll just drop into a node. Oh, by the way, did I kill the other job? Just dropped into. Yeah. So if you want to drop in interactively into a node, please use test queue. Don't drop into a work queue. Otherwise, people will come and blow up that node. And so I'm inside a node now, which is 161. If I do LSCPU, you will see that I am running an AMD EPYC 7742 64-core processor, and there are 2 sockets of those. So basically, 2 such processors are there on each motherboard. And if you look at the, you can see this, that cores per socket is 64, and there are 2 such sockets or 2 such processors. So it's 2 into 64, 128 cores per node, or per server or per motherboard is there. Hyper-threading, which is basically a marketing gimmick by Intel, is disabled because any self-respecting HPC cluster will disable it. Okay. The maximum and minimum frequencies and all these things are here, and L1 and 2. AMD as an architecture is very nice in the sense that it gives a big cache, L3 cache. You can see it's 16 MB. And this 16 MB is actually per NUMA node. Per processor, it is 512 MB currently. The Milan processors that are going to be there are already almost out. Milan AMD cache is 512 MB per processor, I think. It's the third generation of processors. And again, you won't get your stuff because these are server grade things, but where are the specs of this guy? Why doesn't it so hard to get a architecture? What is this marketing crap they keep putting? Where's the specs? Here. So, cache, which is the best one? This looks like the best one. Usually the highest power consuming thing is the best one. This or this one will go with. Okay. So let's see. You can see they have 8 memory channels, DDR4 types, up to 3200 megahertz. Usually, okay, the problem with these people is they will say double data rate 4 and they will call this as megahertz. This is technically not megahertz, it's MTS, mega transfers. Okay. If it was actually the clock speed, then technically you should multiply this with 2 and then you'll get the transfer rate. No, that is not the case. This is actually, the clock speed is actually half of this because it's double data rate. So it's 1600 megahertz into 2 streams of double data rate into 8 bytes. That is your bandwidth. And if you calculate that, it will come to 204.8 GB. No, not that. Into 8 memory channels, that will come to 2.4 GB. Just don't believe me, just do this calculation because, see, this is how you start doing theoretical estimates. So can you just do this bandwidth calculation once? 3.2 giga transfers per second into 8 bytes per transfer. That is the bandwidth of one stick or one memory channel. And you have 8 such memory channels, so into 8. This is coming to 204.8 gigabyte per second. Because see, marketing people this comes right. Okay, fine. Yeah. So this is how you calculate the. So AMD seems to be good at writing specification documents. This is a big no-no, but apart from that, okay. So
Same mechanism happens in mobile because in one of the videos which you posted, it is very well explained.
Which one? Which part?
CPU of a mobile phone. So how data transfer happens there.
Which video are you referring to?
CPU of mobile. I do not remember at this moment. But it was
Also, how do smartphones work?
Yeah. Okay. It is very well explained in that.
Okay, fine. People can go check that video in this repo. How do
Yeah, can you go to that AMD thing?
Yeah.
So they have 64 cores, 8 memory channels. Is it like 4 cores? I mean, each memory channel is assigned to 4 cores, something like that? Or?
Yes, each memory channel is shared by 8 cores.
Okay.
Yeah, and that is the motivation of the next topic that we are going to discuss. Why should we pin OpenMP and MPI threads? Because if you're just running with the entire number of cores, you're basically wasting energy or power. You're consuming power unnecessarily. You won't get performance. You need to know exactly which cores to pin your jobs to get the lowest energy consumption and the best performance.
Okay.
So we'll come to all those things.
Yeah, cool.
How to run codes on properly and so on. So okay, this is AMD. Similar things you can do with Intel also. We did one for Intel, one for AMD. By the way, this is just Intel seems to be very weak of 34 Gbps because this is a desktop grade processor. If you really want to see Intel's the competition of AMD's EPIC, you can go to something called Ice Lake is not released yet, no? It is, I don't know. We have an NDA with Intel, otherwise I could have shown you how an actual Ice Lake is working. No. Oh, by the way, Ravi, Endeavor, you have access to the better Ice Lake nodes actually. Today I gave it to Santosh, the measurements from there. Yeah, 8380. That's the highest grade Ice Lake that there is. Yeah. So Okay, let's do that. Xeon 830. This is the best processor that Intel has currently not in the market per se, but at least for NDA level stuff. So, well, access wise, basically. So, as you can see, where is it? Here. Maximum data, again, MTS that it supports. This Intel and AMD keep misusing this term megahertz like anything. This is MTS. Okay, megahertz would be 1600, double data rate, so into 2, so 3200 MTS. So 3200 million transfers per second into 8 bytes. That is the transfer rate of a single channel. There are 8 channels. So this will also come to, we calculated this 204.8 Gbps. So this Intel's this Ice Lake product, okay, is sort of the competitor of AMD's Milan. So these are currently the best processors that are out there anywhere you can get in the world, and these are the memory bandwidth that it takes. And since we are going to do scientific computation, which are memory bandwidth limited, this is the basic bottleneck you will face. Your speed, the speed of your code will be 99% determined by this number. Okay. The higher this number, the better your code will run, the faster your code will run. That's it. If your code was compute bound, then we will go into all these other gigahertz, the processor base frequency and all those things, and number of cores. So,
so this is per socket?
Yes, this is per socket, yeah. Because this is per processor. So if you have 2 sockets or 2 processors,
Yeah.
it'll be 2 into this 400, 410.
But then how does on Rudra does it come out to be 450? Like the theoretical bandwidth is 450,
yeah.
right?
Theoretical bandwidth is 410, I think, in Rudra.
Oh, 410 now, 450.
Yeah.
Okay.
So let's see. Okay, I was going to show you something here. Okay, let's do one small thing. I'll log into Rudra as the admin only. It's running, right? Okay. So we'll do a DMID code here. You can see, no point in doing this. As you can see, for example, there is a 3200 MTS. See, so nice. Samsung is so nice. They like MTS. That is what they want. So there's a Samsung DIMM stick, RAM DIMM, 3200 MTS. The size of each stick is 32 GB. It's a DDR4 type. So one stick itself will have 3.2 billion transfers per second into 8 bytes, which is that number which we calculated, 20 point something, into 8 would be 204. So basically now you can see is, for each slot in the motherboard, so this is basically the BIOS information in a command line. So in the motherboard, there is this slot, which is called DIMM P0, PANG 0, and these are like nomenclatures to figure out where exactly the location of the actual slot is in the physical location of the motherboard, these things. So you will see that out of this motherboard supports 2 processors. Okay, so let's just quickly clarify. This motherboard, as you can see, there's only one slot for putting one processor. It's a desktop grade motherboard. If you really want to go into a server grade motherboard, let's look for Rudra. What happened? Let's look for Rudra only. What is the motherboard that Rudra uses? Cray rebranded it. It's actually a gigabyte motherboard. Okay, let's search for this. See, nice. So it comes out as this. So let's look at the motherboard actually of this server. This is okay. This is how the server looks like. Okay, like very complicated, but it's actually not. It's just a blown up version of your desktop or laptop. Okay, so if you go into the picture of this thing, you will see that. Can I zoom in? Please zoom in. Okay, nice. Well, this is a chassis. Okay, Each block that you're seeing like this is one server or one node or one motherboard. So each chassis has 4 nodes. That is how Rudra is made. And each of these big chassis are stacked up on top of each other in racks. Okay. So if you look at one motherboard, I wish they showed the actual motherboard. This one. Yeah, okay. Now you can see nicely. Okay, so this is what the motherboard looks like. As you can see, there are, wait, what? Yeah, okay. So this is one motherboard, like there are 2 motherboards shown here, 2 separate servers. So let's focus on one server. One server has 2 slots. This is one slot for a big processor. This is another big processor. These blue bands that you're seeing on the sides, those are the RAM slots. So on each side of one processor, you have 4 slots on the left and 4 slots on the right. So each processor can support up to 8 DIMM sticks. And here on this processor also, you have 8. So in total, there are 16 RAM slots on this gigabyte motherboard. Fortunately, it so happens that this AMD processor also has 8 memory channels per processor. And if there are 2 processors, then there will be 16 memory channels. So you can fill in all the slots and you will get the full bandwidth. There are no empty slots required, and so hardware-wise, it's very clean. So if you now go up this specification of DMI decode, you'll essentially see that there are 16 of these DIMMs. So let's take out a unique identifier number like MTS and see how many DIMMs are there. So we'll do a DMI decode memory prep for like this. Oh, it's just the wrong thing only. Okay, what else is there? What is a unique thing? Type DDR4. Is that good? Please say it's unique. Yeah, it should be unique. Or let's do size. That will tell you the total size also now. There are 1, 2, 3, you see, sorry, 16. 16 RAM slots are filled using 32 GB DIMM sticks. So the total size of the memory in Rudra will be 32 into 16 GB. That is 512 GB per node. So I think this comes to the memory bandwidth part of things. I wish we could go there and take one apart and like investigate, but what to do? Reliance is not allowing their own employees or data center people to come and fix stuff. Forget about visitors. They said next year only. Don't come now. So, okay. So this is Rudra for you. Now I think you'll have some more familiarity and like treat the cluster as your friend now that you have seen the very core of it. So fine. So this is the overview. We'll go into theoretical estimates of codes after this because memory bandwidth wise, I think this is a good enough overview, right? Any questions regarding the memory bandwidth part? See, I have not covered flops or processor clock cycles and instruction cycles and all those things because those we'll put as optional because most of the code that we write, unless you have actually a compute bound kernel, your flops will never be saturated. So it's okay. If it is saturated, then we'll do SIMD and then we'll talk about flops also. Hardware, the processor hardware itself. Like take out the processor coating and look at the transistor level stuff.
So now we don't have to worry about SIMD or any other things. So
for entropic code, yes, you still need because entropic. No, actually, you know what? I was seeing I was looking at the assembly that your entropic generates. It turns out that it's not compute bound per se. It is becoming very badly memory bound because so many temporary variables are being generated. No, it basically starts putting them back in RAM. So basically, in the small f vector that you're assigning as a temporary array, that also is sometimes going off to RAM and again being called back. Okay, so if you do SIMD, you will ensure that all those 16 by 16 values or whatever the sizes of your group and all those stay in the cache. It is not because it's compute saturated. It's just that you're trying to keep all the data inside cache without it going.
again, it's a memory.
It's actually a memory bound operation. Because the problem with the computing industry nowadays is this. Ever since that Mood guy made that back of the envelope calculation, everyone is so much Mood slow. Everyone has been focusing on the transistors and the compute only. That's why compute flops have gone to what? 4 teraflops per server node, and memory bandwidth is still stuck at this 300, 400 Gbps.
Yeah.
And now only people are realizing that most scientific applications are actually memory bound. You increase your flops as much as you want, won't help at all. Okay, your code won't speed up. That is why in next year, Intel is coming up with Sapphire Rapids and AMD is coming up with Genoa. All these are like not publicized or launched yet, so it's all under NDA, the specifications. They are going to have HBM grade memory on the CPU itself. So it will be
NVIDIA.
1 terabyte per second of memory bandwidth itself instead of 400 GB.
Oh yeah. Okay. I mean, interestingly, yeah. Actually, I noticed this speed without knowing all this detail. So when we were benchmarking on NVIDIA, those GPUs.
So yeah. So NVIDIA GPU. But the only problem is HBM is so costly and the data bus is so large. It is very difficult to put more memory. You will not have 512 GB of HBM. You can't. It will be maximum. Genoa and Sapphire Rapids are currently going to restrict per node memory bandwidth to 128 GB, 64 GB per socket.
Okay.
So that's why GPU memory is so low. Because if you see, NVIDIA uses the CoWoS 2 facility of TSMC. No? So,
okay, I don't know.
So there's a reason why it's so low. So,
okay.
So the reason is that on a silicon die, you will get only this. Everyone knows this in this company. It's 300. What the diameter is 300 millimeter. No, so you can calculate the surface area. What is available for you on a wafer. Now the idea is, depending on the flops that you want to put in, you have to put in a certain number of transistors. Okay. Now you can back calculate the area taken by a single transistor, and if you have billions of transistors or nowadays trillions, then you will get the surface area required by your processor. Only that 3000 pi, 3000 square by 2, whatever the surface, the wafer, whatever the area of the silicon wafer is, minus the size of the processor, you will get for your RAM, putting your HBM RAM, because HBM RAM has to be integrated on the wafer itself. You can't have PCIe linked to HBM. Doesn't make sense. PCIe will be too slow to make use of HBM. So it is always onboard memory, HBM. That's why GPUs come integrated with the wafer itself as a motherboard. Okay. Actually, basically not exactly that. They have a separate PCB motherboard, but like most of the big chunk of computing on the GPU happens on this wafer chunk itself. So then, if you actually do the calculation of this area required or remaining for the RAM to fit in, and HBM stacks look like this. So if you look at SK Hynix, Samsung also has HBM. So they look like this basically. Okay, small stacks like this. So this also is the surface area. If you do the surface area calculation now, in that small wafer, minus the processor, you can fit maximum of 10 of these stacks. Okay, and if you do the calculation, you'll find out it'll come out to around 80 to 100 to 120 GB, something like that. So that is why it's limited by area. Actually, they leave a bit of space for putting in the wires also, because if everything is taken up by processor, then where will the wires go? So it looks like this, the integration. HBM die and the CPU, GPU, and the interconnects go like this. And this is the base or the package substrate interposer, all these things. Yeah. Okay. So this is the basic idea of.
Maruti, you were also saying that GPU is
going to come next year. So basically, next year without doing. Did I go off?
Hello.
Yeah. Akhilesh, I think you.
Yeah. No. Carry on, somebody. Yeah.
No. You were asking Maruti. I'm done. Huh? You were asking Maruti?
No. I was just saying. Maruti was mentioning in one of his things that he noticed that GPU is much more efficient than CPU for the same memory and same problem, basically, in terms of the power consumption.
Power consumption.
Yeah, as in given the
I don't
same
know.
RAM, same problem, which would consume more power? Would that be
GPU
a?
will consume more power.
Oh,
Oh,
okay,
is
for
it?
the same
Okay.
problems. No, I think
Because see, the problem is this. The problem is this. It's again memory limitation.
basically you explained here, like till now, no, whatever you explained, that's what is I think happening in GPU. The
Yeah. So
bandwidth is
basically,
really high.
yeah. So although the bandwidth is very fast, the amount of memory per GPU card is only. It used to be only 32 GB. Actually, practically
Correct.
now also you'll get only 32 GB.
And now, yeah.
So to fit a problem of suppose 10 terabyte size, you can calculate how many or 1 TB size. You'll calculate how many cards you need to buy.
Lord.
Each card comes around 300 to 400 watts. Okay, so it
Okay.
will be some 100 into 300 watts. So 30 kilowatts or something like that. You will be spending. Instead, you can fit 1 TB within 2 nodes of Rudra, and each node of Rudra is 250. So within 500 watts, you can finish the problem.
Oh, it's much more efficient.
But no, okay. The thing is this: now, if your code is properly written, then you can act. And if you buy that many cards of GPU, then because HBM is at currently, I think, at 1 or 2 terabyte per second, and Rudra is currently at 350 Gbps effectively, then it will finish off 6 times faster. So now you have to do that cost analysis.
Got it.
But last time we did, that's why we didn't go for GPUs in Rudra, because till now, the V100 GPUs, the price power performance ratio was 10 times worse than for our set of problems than compared to a CPU based node. But with the A100, it is slowly changing. GPUs are becoming better, minus the large, small memory size issue. GPUs are actually lesser power hungry comparatively compared to V100s. The A100 is less power hungry. It has a bit more space, memory space. It is 80 GB of onboard memory per GPU compared to 32 GB.
Oh, it has 80 GB, is it?
Yeah. The server grade A100s are 80 GB. Like server means they're really good data center server grade GPUs are 80 GB.
Yeah, okay.
Intel now is like saying that we will put 128 GB of HBM. You come by Intel GPU. It's called Ponte Vecchio. It's coming out again next year, middle of next year.
Oh, okay.
I mean, Intel has GPUs. These are like server grade GPUs which are supposed to compete with AMD, NVIDIA, and AMD also. AMD GPUs are apparently very nice. MI200s, performance-wise. You haven't relaxed.
New Apple laptops have that, no?
Oh no, that is M1 Apple ARM chips. Those are CPUs.
No, I think for the GPU.
No, it has both CPU and GPU.
But
I have it.
MI100 will not be the MI200 is not the GPU in the Apple thing.
Oh, I don't know if.
No. Apple has this ARM64 SoC.
That is the CPU. The GPU
No, that's
is
CPU plus GPU.
It's a CPU plus GPU. Okay. It's like the mobile phone thing.
Yeah, 8 cores and 7 core GPU.
Okay, so they're following the Intel model. Huh? So Intel also has a. So if you go to any of these processors, no, for example, you'll also see a GPU specification alongside this, not the server grade ones, the desktop grade ones. So if you go here, for example, so this is my desktop's processor. Huh? So apart from the server, the processor itself, you will see it shows processor graphics here, Intel HD 530. So Apple also does something like this. On the chip itself, it integrates CPU and GPU. But these are very weak. Like you can see 350 megahertz. Who will do what? Only your PUBG won't even run on this. Yeah. Okay, so I think we have overshot the break entirely. We will break now and meet at, what's it, 2:30? 3? If you meet at 3, there is no...
Like, 2:30, I think.
2:30. Okay.
Yeah.
Okay, then we'll...